using them to make some calculations of some systems of equations and so on. And now we are also trying to find the right hardware architectures to provide us a better performance to achieve AGI state. And of course, there are a lot of questions about software part of the AGI, and there are a lot of potential ways. For example, maybe it's some mainstream connectionist models because of huge success in deep learning, and a lot of people considering that it's the only way to achieve AGI. But of course, there are a lot of some other non-mainstream ways, for example, spiking neural networks, or some completely non-connectionist models, some symbolic models, or some near-symbolic models, and it's still an open question which models will lead us to AGI. But of course, the progress in deep learning gives us some insights about the possible way, and we see some row of revolutions inside deep learning. We have such a lot of innovations in past 10 or 20 years by creating some completely new models. And of course, transformers is one of the maybe most widely known model to be like the candidate model for the future AGI systems. And you know, there are a lot of research how to improve the basic architecture of transformer to achieve better and better results. And you know, in one hand, our current generative language models look like really simple models. They just trying to predict the next token in a sentence. But surprisingly, a lot of intellectual tasks could be easily transformed into the form of predicting next token in sequence. For the past year, of course, the most famous result was GPT-3, and a lot of people consider that it's a really huge leap towards artificial general intelligence, because such a model could achieve really good results solving a lot of different tasks, not the only task. We are living now in a world of huge pre-trained models, but how we can use them in our industry, in our practical tasks. Of course, there are three most popular ways how to do it. Make fine-tuning of such a model for your particular task. For example, when creating some dialogue systems inside the virtual assistants, we using such approach, but of course it needs a lot of computational time, and of course a lot of data and so on. And there are two really interesting alternatives. The first one is to ensemble, to create an ensemble with some shallow model to finally achieve some results you need in your task. Or prompt design, which is considered as software 3.0. You know, there are a lot of really interesting implications in this area. Prompt design, you're now not designing a huge data sets, huge created data sets. You just working on some prompt. It's really small, but it's enough to drive huge pre-trained model to grasp the idea of your task. There are a lot of other consequences for such models. For example, this renaissance of mainframes or cloud computing. We now again living in a world where computational power costs more than maybe time of programmers. It's really interesting. And also, we are now living in a world where we have a lot of cheap content. For example, it's easily to use GPT-3 to create some horoscopes, some rewritten news, and so on and so on. It's really easy to create some faster prototypes. Because you can just design some prompts for GPT-3 or other huge transformer model, and voila, you have a working prototype without consuming a lot of programmers' time. Of course, we are probably approaching a world of highly customized services and highly customized content for each customer. So we are able now probably to create some highly customized news, highly customized music, highly customized texts, and so on for customers. And of course, it's a way towards AGI, and let's see how much time we should now spend to achieve our result. The final considerations on this area, which things we should probably try to achieve our goal. Of course, the reinforcement learning is really an important thing because our intelligence is based, of course, on some natural reinforcement process, and to create some socialized AI, we probably should create some reinforcement framework to updating it, so it's probably it's a time to combine the huge transformer models with some reinforcement frameworks. And of course, we need some multimodal pre-trained models which will join together the texts and image and probably sound and so on. So memory transformers and other explicit memory models, probably it's a really interesting area to explore. Of course, we are continuing some upscaling, some more computational power to be invested into models. And and last but not least is our attempts to simulate brain processes, and of course some huge huge hardware potential enables us to make some more experiments in this area. So from my point of view, this is the first things to try for now.
Thank you, Sergey. You actually mentioned we have very little time for questions, and we in fact have a question. And you mentioned the models which come across images and natural language. And the question in the chat is, to which extent we can extend transformers to replace LSTMs for tasks like image captioning?
I think that there are a lot of ideas how to combine them, how to use transformers with some convolutional neural networks. You should just create some bridge between features of convolutional neural network and transformer natural language features. And there are a lot of ways how you can do it. So I don't know which way finally will win the prize, but of course there are a lot of alternatives here, and of course to combining some image transformers with natural language transformers, and of course image captioning looks like some task where we naturally have some data. We can just to crawl internet and obtain some text data connected with image data, so it's captions for images. Yeah. But I think it's not the only data sets that could be used in such tasks. I like YouTube, for example.
Yeah.
You have some text and images there.
Thank you. So before we close, just maybe 1 minute from Mikhail and from Grigory, how do you see the future, like the next few years in the field of AI? What breakthroughs?
I think that we will see new breakthroughs in creating better language models, and also combining these language models maybe with other modalities like a video or images, and like creating multimodal models. It's what we are doing in terms of theory, but I also think that in terms of challenges, still the dialogue systems and conversational AI is the most challenging, because it combines online learning with pre-trained models, all these stuff for transfer learning and so on, because it's interactive. It's not like training on a static data set. You cannot predict exactly what the human will do in the chat. So it's much more interesting, and to create model which can online learn something from a user is a great opportunity.
And Grigory?
As for me, I see a very broad frontier from multimodal models, huge models, new architecture improvements, but two important things is AGI, Sergey mentioned it, and another thing is human augmented intelligence, because we have a kind of integration problems. We have a lot of narrow AIs, but it's hard to use them in an easy way. We have a vast potential of improving integrations with these even narrow models, and it could bring us much more efficiency in almost any area.
Right. Well, thank you so much for this panel. I think we have not covered half of the things that I wanted to, so we probably would need another one during the next conference. And with this, again, thank you so much. And we will now run a short commercial before our next session.
Hi everyone, welcome back. So gosh, we are running through all of these sessions one after another, and we are going to get straight into this one as well. So I would like to say hi to Soumya. It's so great to see you. Could you do a quick introduction for us?
Yeah, hi, my name is Soumya, and I'm going to be taking your session today on how to build a quiz generator from your notes.
Oh my goodness, I'm sure this will be really useful for all of the students and people in academia in the audience. And I know you're going to be using the Azure Cognitive Services. So yeah, feel free to take it away and share your screen, and then we'll come back at the end if there are any questions.
Just give me a sec.
No problem. Okay.
Can you see my screen?
Yes. So if you present it, there we go. Yeah, we can now. There we go.
Then. So hi everyone, my name is Soumya, and I'm gonna be taking your session on how to build a quiz generator from your notes. Let me just introduce myself. I'm Soumya Narparaju. I'm a junior at GNETS. I'm a pre-final year student. I've been a Microsoft Student Ambassador for about a year now, and I'm the IEEE Secretary of my student branch. I'm genuinely passionate about technology and I'm a complete bookworm. So let's jump into why we need to build a quiz generator. So usually college students or students around the world, high school students, we write so much of notes. We continuously write notes in every single class, and on an average, as I stated in the fact here, on an average, students will take about 30 to 45 classes each semester, and that gives out 200 to 400 pages of writing. When we usually try to prepare for an exam or when we're trying to revise to our notes, what happens is we try to go through 200 or 400 pages of worth of notes. So that's a lot of notes that you have to read, which is technically it would be impossible, but we students make it possible. So what my idea when I first started out this project was, why can't I make this easier for me? Why do I have to read every single page of every single paragraph? And let's make this easier. So what I did was I built a quiz generator. What a quiz generator, when you usually use it, you don't have to go through every single point of your notes, and you could just you could just take the important lines and important sentences from your notes, and then you could create a quiz from it. If you go through the quiz, you would automatically go through your notes, which makes it completely easier for you to understand what you were going through the notes, what happened in the class, and whatever you needed to learn for or revise or go for your exam. So how do I make this come true? How do I have a notes which is on a notebook and it's physically on a notebook, and I need a quiz generator on my laptop. So how does the process in between this even work? So what I did was, usually we use the OCR API. So what I did was I have a note. So I took a picture of my notes and then I put it through the OCR Azure Cognitive Services OCR API. And well, a bit of data science code added with it, and I got my quiz. So I'm going to explain how the code works and how the Azure OCR API works, and how could I replace this with other APIs. So when we go through each step by step of this process, genuinely we have 7 steps of this process. We take the picture of our notes, we put it through the OCR API, we extract the answers that we need from this paragraph or text that we have from our notes. We generate the keywords of whatever are in the paragraph or text. We predict the keywords, and then we generate the questions based on this, and then we give it out as a quiz. So if we want to give it out as a quiz, we have 3 types. We could give it out as a multiple choice quiz, we could give it out as a long paragraph quiz, we could give it out short, or you could actually just pick out the important points from the notes and then frame it as questions, blank space or multiple choice. In this, what I'm going to do in my project, what I did was, I took a sentence, give it a blank space, and whatever you have to fill in the word. And for the word, I would give you the correct options for whatever you have to fill in the word. And then we would also predict the incorrect words from it. So it would basically be a form of natural language processing, where we take a text, we read through each sentence, we analyze it, and then we find out whether the text is, which parts of the text we could take it as an answer to a question, and which part of the text are incorrect answers to whatever the question is. So that would be a major part that we should be focusing on. We usually what happens when we write an exam is we get confused between a right answer and a wrong answer, and the difference between that is, when we read a sentence, we only read what is in that sentence, and if we don't remember it correctly, we get confused with the wrong answer. So to make it a bit more efficient for the quiz generator, I also produce the incorrect answers. So the Azure Cognitive Services, what happens here? When I use the OCR API, you have 2 different types of optical character recognition APIs on cognitive services. That is the OCR API and the read API. Both of them, well, technically speaking, they both work the same. We give it a picture as an input. It recognizes the words in it, gives it as text. But what's the difference between both of these APIs on cognitive services? So in the cognitive services, computer vision, what happens is the OCR API, if it has like small amount of text in the images, you could get that easily. But the read API, if you have a text or a picture where you wrote like continuously 50 lines of words or paragraph, a complete paragraph on it, you would better go with a read API. So this depends on what your notes looks like, on what your picture that you're giving to the API looks like. Because usually when we write notes, this is a kind of a case, two different types of cases that we can see in the notes. If you write your notes really roughly and you don't jot down a lot of points, and there's a lot of space between two lines, and the text isn't as dense as what you usually. It also depends on the subjects that you're using, so that would be a difference. So you need to select each one of these if you want to go for an OCR API or a read API. Both of them usually return the same stuff. You could get the regions in the image that contain the text and the lines of the text in each region and the words in each line of the text. And the read API also gives the same, it's arranged into the same hierarchy, just a little bit of difference, which we usually oversee. But when you give it good thinking and when you consider the image that you're giving into the API, this would create a major difference. So let's go further. How do I use this OCR API in Jupyter Networks on Visual Studio Code? So if you worked with Azure before, you would know that you need to get a cognitive services key and a cognitive endpoint. So if you need to get this cognitive endpoint, you need to go to the Azure Cognitive Services, create a service, and then go to the Machine Learning Studio, create whatever API that you need, and then you have to create this. Create whatever API that you need and take the cognitive key and the cognitive endpoint of that key. And then what happens is you give the nodes as your input, and then it gives it back as the text. So what happened was, this is a screenshot of what you would get if you use Azure Key Vault in the Cognitive Services API. You need to use this key here, and you have to copy paste it here. The key is unique for each and every key that you generate in Azure. So it's a must that you have to have the key and the endpoint here. This is my endpoint. So you have to, it's unique for you. You have to use that for the OCR API to make your OCR API work. This is the same thing that happens with the read API on Azure too. So if you're trying to use read API, you have to create your read API service on Azure, and then in this cognitive key and cognitive endpoint, you have to replace them with that. So that would be what you need to do. To get the text from your notes pictures, what you need to do is you have to use the computer vision API. If you want to work on Azure Jupyter Notebooks on Azure Machine Learning Studio, you could use this. You don't have to use this code, and you could directly use it there on the Machine Learning Studio. But if you want to import it into Visual Studio Code, you have to use this code, which is available on Microsoft's GitHub, on the Cognitive Services Microsoft GitHub. And if you want to like get your text data from your node picture, you have to upload it to your Visual Studio Code in the same file, and then run this data with your Cognitive Services key and endpoint, and then you'll get your data. So till now, what we did was we used our Azure Cognitive Services and we got our data, but we need to build a quiz from that data. So what do? I used PICKLE in my project. Usually we use PICKLE for byte synchronization and data science. So usually what PICKLE does is if you have like a feature engineered data, and if you want to save it, it works for both data and the machine learning model. So if you want to save your machine learning model data or your machine learning model without training it over and over again, you dump the PICKLE. And then if you want to use it, you load the PICKLE. The PICKLE exists is I was actually checking if the Python object got PICKLE. So this would you could use this, you could skip this part, but it would be better if you use this part. If you use PICKLE in your project, I included the PICKLE documentation on whatever you need to know about PICKLE in the resources group. So if you have any doubt about PICKLE, you could head over to the resources on the AI Student Conference resources webpage. Next, we need to extract the answers from the text. Well, we have a text right now, and what we need from this text is we go through each and every sentence, and then we have to check which one of them is an answer. You have to, if we take the sentence, oxygen's atomic number is 8. What you need from this text is, you don't need atomic number, you don't need oxygen. What happens is you could use a blank space as oxygen's atomic number is 8. So oxygen could be a blank space, atomic number could be a blank space, and 8 could be a blank space. What all these are answers to the text. So we need to extract these answers from the text. So how do we do that? So firstly, what I did was I use Spacy. Spacy is an open source Python library for information extraction, and usually natural language processing. So what you could use Spacy in this manner. So this text in this text, what I did was I checked the answer of each and every sentence. I took the length of the sentence in the text, and then I checked each of the sentence, and then I added it. So I got the answers from the text. So what I needed to do was I needed to predict whether the word was a keyword or not. So I know what the word is, but I need to know if it's correct or not. So you could use this. You need to generate a data frame from this. So what usually would happen is you have a word like, again, let's use the example, oxygen's atomic number is 8. So here the keywords would be oxygen, atomic number, and 8. So how do I know if this is a word is a keyword or not? And if it's a keyword, I need to store it. So we have two data frames, right? One of the data frame is with the text that you got from your picture in Azure OCR API or read API. The other data frame that we need to use is this words that we got from the data. So we create two different data frames. So in the end, we check every single one of the words, and then we return this data frame. And then you need to predict these keywords. Usually we would do that using you just load the pickle you got from here. You save the pickle, right? You dump the pickle. So you just load the pickle again. And then you check each and every word in that. And then you have to append it to another data frame, and then you get all the keywords to it. So right now what we have is we know what the answers are. We know the data frame. We have a data frame of all the words that have keywords, and right now what we need is the blank answer. So what happened was when we usually define a blank answer, so let's take the example again of oxygen's atomic number is 8. If you take the answer as atomic number, you have oxygen is, and atomic number, if you take it out and put it as a blank space, we have is 8. So you have text on this on the left side and also text on the right side. So you need to store this somewhere as a question, right? Atomic number, oxygen's dash atomic number dash is 8, and in the blank space we have atomic number. So we have to write code for that. You get the left part of the code and the right part of the code, and then you add a blank space in the middle. So that would be what we need to define the question. The next one is find the questions which have answers. We took the sentence oxygen's atomic number is 8, but for some sentences, suppose we have a sentence that does not have an answer, like a continuation of oxygen's atomic number is 8. It is a halogen. So what happens is, what is it? You don't have any answer for there, and you have to detect the answer for it, right? So we only have to find the questions which have answers to it. So that is another important thing that we have to check. And we could check it by this. We have to take each answer as a token and check if each token has an answer to it. And if it doesn't have an answer to it, then you remove it. Or you, if it does have an answer to it, return it as a question and answer pair. So it's a question and it has a pair. It has an answer as a pair. So we have to find the questions which also have answers instead of only the questions which are a bit like which do not have answers basically. And then we generate the questions. So you saw all of these functions, right? So from all of these functions, it's in a Jupyter notebook, right? So we generate the questions from all of these functions, and then we predict the words, we add the questions, and then we add distractors, which I'll go over. And then you have to print these questions. And next, distractors. Distractors, usually what happens is we give it as the incorrect answers for the text, and then we we use distractors and GenSim, which is also an open source Python library which we use for natural language processing. And then by using GenSim, what we do is we generate the distractors, whatever the wrong answers that you have, and then we give it out as an output. So what we would get is, we define the OCR API, we get the cognitive services, and then we define all of the functions that we need in this to generate a quiz. The predict word and the predict the keys, the word is a keyword, and every single one of those. And then we generate the distractors and then the main functions to generate the quiz. And then we get our output. This is the text that I got, and then I generated 10 questions from this. So I took the text, I gave it as I want 10 questions, and then each one of them, they give the question. The question contains of a left side and a right side and a blank space in the middle, and it contains the answer and the incorrect answers for it. So we suppose dash oxygen gas consists of 20.8% of the Earth's atmosphere. We have the answer and the incorrect answers from this. So that would be the project. And well, our quiz is ready. We got our notes, and then we have our code, and then we used it Azure Cognitive Services OCR API, and then we made a quiz from it. So that would be the project that I did. If you want to go over this, or if you want to enhance this better, you could do it two ways. These were actually my ideas. If you want to do them, you could implement them, and you could reach out to me and tell me how you implemented them. You could reach out to me on LinkedIn. So what you could do for these projects is you could integrate it with Power Platform and create a Power App such that a person could upload their picture, put it through this code and to the OCR API in the code, and then it would return them a quiz. And second one would be, you could use a little bit of deep learning, and then what you could do was, if a person uploads a text, the text immediately goes to the internet, does some web scraping, find out which parts of the text is an important parts, what are the other questions that we could expect from this, and then it returns extra questions, not only the ones in the text that we have. So that could be two possible stuff that you could do from my point of view. If you have other point of view, I'd be really delighted to hear them. So yeah, that's the quiz time. So anybody has any questions, you could post them on the chat, and yeah.
And I will ask them to you. Thanks so much, Soumya. That was really great presentation. I like that you combined cognitive services and OCR and Spacey into one project. There is one question. What happens if OCR makes slight mistakes? How do you handle that?
Well, what happens is you could write a more efficient code so that when you take the OCR API and it gives like a slight glitch in it. So what would happen is you could use a bit of web scraping or stuff like that, and then you could check with it would actually overlook this and predict whether a question has an answer or not, because if it gets a different type of glitch in it, it would not give it as a question at all, a question with a pair.
Yeah, actually, you can also use the cognitive service for spell checking because it has the spell checking capabilities, and that would help eliminate some of the small mistakes that OCR might do.
You could also use the Q&A bot, which Jahnavi and Jayesh were talking about in the Microsoft Learn walkthrough. This was actually a follow-up project of what you could do after learning those.
Yeah, that's exactly what I wanted to mention, that after you generate the quiz, it would be good to run the quiz as the part of a bot. So you generate questions, and then you can have the bot where people would answer those questions. And this actually sounds like a good startup, like you take a picture and you have the bot created, which automates the whole process. There was also one question in the chat, like, do you have to use Python for this project?
Well, it's not a compulsory of a Python. If you know any other languages like JavaScript or whatever languages could work when we get the output, any language that you could get. This is my point of view and what I know I did for the project. If you have any other like types or any other different ideas for the project, that would be like completely amazing.
Yeah, actually, from Python specific things, I think what you use NLP capabilities, right?
Yeah.
You use Spacey.
I used a lot of Python libraries.
Yeah, so in this project, like, you cannot avoid using Spacey, and Spacey is something like quite Python specific. So that would be difficult probably to find. Well, it's possible to find the replacement in other languages, but Python, of course, is unparalleled for that. If you move outside from that, cognitive services, they are accessible from any language. It's just the REST API which you can call, right? So like for creation of the bot, you can use C#, you can use JavaScript. For the initial part, like doing OCR, you can also use any of your favorite languages. But yeah, with NLP, Python is probably.
If you're trying to use exact the same libraries that I'm using, then maybe you should stick with Python.
Yeah, can you envision some kind of further development of this project? Like where would you like to take it?
I was actually trying to get into the web scraping so that when we have a text, you search it in the web and then you give it it gives you an answer such that you don't get the questions from the text that you provided and also from text from outside. And I wanted to integrate that into Power Apps so that you could get like an app for it without like a no-code, low-code platform type. So that would be a really amazing development to this project.
Or maybe you can write a code which would scrape the whole Wikipedia and create all possible quizzes from it, and that would be like a mega quiz.
And then integrate all of it into Power Apps.
Yeah, so there are a lot of directions you could take this to. And actually, there are a lot of comments in the chat. You can go and check them out. They all like your project quite a lot. So I think all of the questions we have more or less discussed. And yeah, otherwise, go and see a lot of nice comments towards you. So we are coming to our next session. I think we can play a short commercial and then proceed with the next session. So thank you everyone for staying with us. We have our next session now, and I would like to introduce Raghav, who is a student ambassador and who will tell us about handling sound and audio information with AI. Because we've talked about handling text, we've talked about handling images, and now we'll touch the topic which is less frequently discussed, audio and sound. So Raghav, the floor is yours. You can introduce yourself, share your screen, and start presenting.
Yeah, thank you, Dimitri, for the introduction. I'll try and share my screen.
Excellent.
Yes, I think it should be up now. Yeah.
Yeah, we can see it.
Yeah, okay. Hi. Good evening, everyone, according to the India time zone, and good morning and good afternoon for wherever in the world you are. So I'm Raghav Rawat. I'm a Microsoft Learn Student Ambassador, and I'm an undergraduate student at RV College of Engineering in Bangalore, and I'm majoring in electronics and communication. And yeah, so today I'll be talking about the rather less explored field, at least according to me, in the domain of artificial intelligence. And yes, I would try and give a different angle to today's conference. And I hope you loved the sessions, whichever happened up till now. And I hope you're going to enjoy my session as well. So yeah, let's just start off. So the discussion points for today would be, first of all, I'll try and introduce you to sound recognition, which is, again, a relatively a feature of artificial intelligence, which is highly probable to be seen in day-to-day devices and other applications. But yes, let's try and look at a rather an under the hood aspect of sound AI, and let us understand what actually happens when we talk about sound recognition, speech to text translation, and vice versa, things like that. We're going to talk about sound recognition today. We're going to be seeing how AI in sound is linked with the signal processing, which is again a subject of deep research, and how some typical aspects from signal processing are ultimately used up in the computation of the computation and generation of the data, which we're going to ultimately be using for our neural networks. So yep, that's the surprise. We are going to be using deep learning for doing our sound recognition, and another really important library, which is the Librosa library. So we're going to be talking about that as well. And yes, so Librosa is again an open source library, just like other Python libraries. We're going to be using TensorFlow as well. And Librosa specifically has been developed up till now for music generation and classification, recognition, and things like that. And hence, you can say this is has proven to be a really powerful library for this purpose. We're going to be talking about the model requirements, which we have. Where like a lot of people come across CNN models and like different architectures for computer vision applications. But what do we require for actually the speech translation or text-to-speech translation? So there's a bit of difference here. Let's look into that today. And yes, I'm going to be using a CNN model as well, but with a little bit of difference. And many of you would be knowing that sequence models, NLP, and other applications use RNNs and other networks like LSTMs and stuff. But I've tried to implement a project based on CNNs, and let us see how that works out. So moving on. Yeah, so how is the sound intelligence performing today? So recently, there was news about the Qualcomm 888 5G configured chipset. And So here the audio analytic has, they have proven that their software, which is the AI3 nano sound recognition software, it is efficiently performing translation and audio assisting the platform, which is basically enabling our day-to-day services and day-to-day activities. It's been aiding day-to-day activities of the visually challenged people, and ultimately the research and experimentation was concluded by the fact that they were able to deploy a software with just a 40 kb of capacity on the chipset, which is actually a great leap in the field of audio assistance. And another really interesting piece of news was when an IITian lost his vision 8 years ago. So his name is Pramit Bhargav, and he has recently developed a voice assistance app. So what the app is doing is basically it's enabling the people to utilize their day-to-day devices, such as mobile phones, and he has developed an app which enables a visually impaired person to exactly and efficiently utilize our devices just by internal execution. The app is able to recognize the display of the devices and ultimately give recommendations according to the user. So, for example, today we have been using apps like Uber and food services like Zomato, and then there are other services like Big Basket and stuff like that. So we have been seeing this trend where the people have been moving on and into the sound AI as well. Yeah, moving on. So how is sound recognition going on? Today, the state-of-the-art architectures are with the CNNs, bidirectional LSTMs, and also transfer learning has been of immense importance in the field of sound recognition. So, and also we have cloud services like Microsoft Azure, speech recognition services. There was a brief talk about it in Sammy's session, but I'll also hint upon it, like how the workflow is going on. We then have the speaker recognition API, yeah, again from Microsoft Azure, then .NET Speech SDK, which is also a really powerful tool. And then we have from AWS, we have recognition and transcribe. These are the powerful cloud ML services, which is being used up in the sound and translation AI services. Yeah, so talking about the API workflow, it's really as simple as any other cloud service where we create a resource group, then we obtain the key and the endpoint for the user. We connect it to the relevant cloud and pricing services, and then we're able to just with the call of an API, we're able to use up the service in an instant. And this can be used up in two ways, with REST API as well as the speech SDK. Also, Microsoft Azure provides a lot of a variety of voice pools where you can use up different the voice and accents from different regions across the world. So, and it goes to a deeper specific to much deeper specific regions. Like for US itself, they have different voice pools from US West, US Central, the South Central US, East Central US, and thus they have Asia and others, to name a few. Yeah, so you can try it out yourself. You can check out Azure documentation, and I think the links would be provided in the resources section. You can also check out this amazing Learn module on language translations using Emotion, and it just requires you to give your 70 minutes. You should definitely check it out. Yeah. So what is the link of sound recognition with signal process? This might be a bit overwhelming to see, but we'll come back to this. Yeah. So first of all, what is a Fourier transform? So I don't expect everyone to be knowing a Fourier transform, but yes, coming from an engineering background, I can give an overview of it and like how it is being used up into basically process the input audio. So a Fourier transform is basically used up to convert the time domain representation of signals into their frequency counterparts and to check off what components of frequency are giving how much value and strength to the ultimate amplitude that we have for the signals. And this plot comes out to be something like this. And this is consisting of no information for sound, for time, but this is purely for the frequency domain. So why are we using Fourier transform? Yeah, so basically a Fourier transform splits up different sound signals into their component signals, which are really rudimentary in their composition. So for example, a Fourier transform is able to split the signal into different sine and cosine waves, and ultimately computation on these waves become easier when they are more and more into their rudimentary forms, into their simpler forms. Yeah. So another important point about this is Fourier transform work on fixed time frames. So because of that purpose, we are able to compute a given aspect of the audio signals, because of which we are able to, you can say, construct a specific architecture for the neural network. And yeah, so yes, in that manner, we ensure that the neural network does not break, you can say, on each epoch. So you can basically, with important pre-processing tools like these, we're able to focus more on the deep learning aspect and not on the audio pre-processing. Again, one more thing of importance is an SFTT, which is a short Fourier transform, which is again done on even smaller intervals, because of which basically we are able to work on even more data, which you'll be getting idea about in the coming demo session. So we have something called a spectrogram. So a spectrogram is basically a decibel plot. Again, a decibel is a logarithm of the amplitudes of signals. So the spectrogram is more towards the natural tendency of human beings in their perception for the audio. So this is a realistic view of how humans perceive audio, and that's why this is a really important step. Computation of spectrograms is really important here, and it's basically a plot between time and frequency along with a color map, which can be basically seen as a heat map. So you can see, yeah. For your information, we have I have used up a piano audio. So when you play a piano key, you have a high decibel sound initially, and it gradually transforms into a lower decibel sound and ultimately fades off. So this is being signified here, where the lower frequencies in the initial time components have a higher proportion of the map, and gradually towards as the time moves forward, we are seeing a lesser component for the same. So our pre-processing pipeline is something like this, where we have the sorry. So we have the frequency representation, which is being ultimately used up for obtaining the spectrogram maps. And then we use these spectrograms to extract something known as MFCCs. So it stands for Mel Frequency Cepstral Coefficients. I'll be expanding more on that. So these MFCCs are the numerical data which we'll be using as an input to our neural networks. And when we talk about prediction and computation, what the neural networks are doing is basically tuning the data to figure out, tuning the data as per the MFCC coefficients, and to ultimately to figure out what the nature of the audio is. And this is again happening only on basis of the MFCC coefficients. So yeah. So expanding on MFCC coefficients, they are numerical data again, which capture the texture of the sounds. Yeah. So if you see this map is an MFCC versus time map, where you can see different segments, sections. So just for the information here, we have 13 segments here, and I'll let you know why there's a fixed number. So this is again for the same audio file.
Hi, Raghav. Sorry to interrupt. I think you just muted. Could you just double check and unmute for us in Teams? There we go. There we go. We hear you again.
Yeah.
Apologies for that.
Okay.
Sorry to interrupt. Keep going.
Yeah,
it's a great presentation.
Sure, sure. Okay, thank you. Yeah. Moving forward. So this is completely based on the human perception, and that's why we are trying to extract as much amount of MFCC coefficients which are required for the efficient computation of the audio types. And hence the given and the researched out range for the coefficients is about 13 to 40. The number 13 is significant to music, and again, like it's a little out of scope of the talk, but yes, for the timing, let us see it the way that 13 MFCC coefficients are basically the dimensions, the number of dimensions in which the sound data is being represented. And we're not going for more number of dimensions, as again, it adds up to the computation time, which is required for the training of the neural networks. So we'll see how these coefficients are computed in a code run through in a while. Yeah. So again, it's a quick overview of the process. Is we take a Fourier transform of the signal. We map the signal according to their Mel scales, which is again a scale according to frequencies and pitch. So it's a direct linear mapping. And then this scale is used for something called as triangular overlapping. For people who are very much interested in the same, I think the links will be provided in the resources section. You can definitely check them out. And so this is being used up to compute the decibel ranges by taking off the logs of the powers and ultimately the discrete cosine functions of these Mel scalings. And yeah, so this is the numerical spectrum which we'll be receiving for a given audio file. Here you can see a short representation of what a 13 value MFCC array would look like. This is for an audio period of 0.6 seconds, and I'll tell you how this is being computed in the demo. Yeah, so pre-processing with Librosa. So this is, again, as I told earlier, an important open source library which we'll be using. So audio visualization with Librosa is very easy. So this is, you can see it's Jupyter Notebook snaps where we're seeing amplitude. I'm sorry. Amplitude versus time representation of the signals. And this graph is of a car horn, and the graph below is of a dog barking. And you can clearly see why is that so, because a car horn is a continuous and elongated interval, whereas a dog barking is of short intervals but with high decibels. You can see how easy it is to sort of load the audio data and get a representation out of them. So I'll be going through this in the Jupyter Notebook. Yeah. So talking about Librosa features, we have some really important sub libraries out of the main Librosa, which are being used up for audio pre-processing. We have Librosa Beat, which is used for estimating the tempo of, you can say, music and other sounds. This is of importance with respect to music generation and classification. We have Librosa Display, which is basically using matplotlib routines to display spectrograms and other stuff. Then we have Librosa Filters, which is basically used up for, you can say, predictive filtering and other filtering of the audio files. And thus, moving on to Librosa Sequence, this is a really important sub-library for sequence modeling and the encoding and decoding of the signals, which is used up, again, within the other core libraries of Librosa, such as librosa.feature. You can check out the official documentation. I guess the link would be shared. So moving on. Yeah, so I'm going to be putting up a demo now. There will be four important Python scripts. The first we have is the preprocess.py, which is basically extracting the MFCCs from raw audio files, which would be in .wav format. We'll have a simple feed-forward neural network, which would be having a dropout regularization aspect just to resolve the overfitting. Then we'll be trying out the CNN model and see how we're able to recognize sounds with the CNN model. And where we have seen the application of CNN more in computer vision and its applications. So ultimately, we'll be using the predictor.py file, which loads the train model, and it is taking up completely unseen audio files and trying to predict, the class of the audio or the speaker. So yeah. So okay, I'm really sorry for such a beautiful annotation, but yes, let's quickly move forward with this. So this is the workflow which I'll be employing in my demo. So we have preprocess.py, which is again extracting MFCCs. This gives us the output, a file data.json, and which is again seen as a Python dictionary. And this comprises of the MFCCs, the labels for our data, and hence this format is essentially used up in training of our deep learning models. Our model would be dropout regularization, or CNN here. And this script would be training the model. And this trained model would be saved and then loaded again in the predictor.py file, because this predictor.py file would internally be taking in a raw audio file as an input. It would be computing the MFCC coefficients from the audio file, and then it would be trying to predict the class of the audio or the speaker from the trained model. And that is how we'll be having basically the ultimate test of the model. So yeah, let's jump to VS Code for the demo. I hope my VS Code window is visible. Yeah. So we have preprocess.py open. We load up the important libraries, OS, librosa, math, and JSON. We give dataset path, JSON path, and we have sample rate here. So sample rate is an important component again, where we take continuous distributions of audio files. And again, this is of importance from the signal processing aspect. This is basically sampling, or you can say considering very tiny intervals of our audio signals and computing our further preprocesses onto the sampled representations. So this is a general constant of the sampling rate that we use. Coming down to the second constant, there is duration under consideration. So basically, I'm trying to take up 3-second audio files, which would be helpful for the faster training of the model. And also, it is a decent enough length for for the efficient training of the model. So moving on, this is a general a very important function in this Python script. This is generating the MFCCs. We give the data set path, we give JSON path, we give the number of MFCCs that we require, and we give a number of basically the fast Fourier transform window that we want to compute from the audio file. And these numbers, NFFT and the hop length number, these are in terms of samples. So this is the number of samples which we'll be computing FFT on. And this is basically the amount of shift that the FFT window would be doing after each FFT computation. So, and yeah, hence we'll be basically jumping 5 and 2 samples after each computation. And the number of segments is the number of parts from each 3-second audio file, which we are considering. So you can say ultimately there are 5 different data points from each audio file. So we'll see the use for it afterwards. Now we have the representation of data. This is done again in the form of a Python dictionary. We have mapping, MFCC, and labels as the keys. And mapping would be automatically filled up. Again, we'll see how this is working below. But you can say mapping will consist of all our classes. MFCCs would consist of the data points and their corresponding coefficient values. And the labels would consist of basically the final result which we'll be training the data on. So I think there will be a shortage of time. So I'll just quickly go through the file. I'll first run this, or let us just complete the walkthrough, and I'll show you the final result. I think that would be good. So here, this function again takes up the path directory, the data set, data set is stored up in our local root directory, which I'll quickly show to you. Yeah, so this is our root directory where we have 5 different classes. We have a dog barking, an ambulance, a fire truck, and the sounds of general traffic. So I'm sorry, there are just 4 classes. So let's just quickly see how this is being represented. I'll open my JSON file, one of the JSON files, to show you the representation. Yeah, so this has the MFCCs only, for since this is a test.json file. So there isn't any label at the moment, but this is just the MFCCs of the data. Here is the data.json, which I was talking about earlier. It will take a bit of time to open since it's a huge file. Yeah, so here we have mapping and MFCCs. So you can have an idea like what this file is, how this file is represented, basically. Yeah, so this is the file which is extracting the MFCCs, and this is dumping the MFCCs into a JSON. That is the data.json. Again, I'm not starting the training. I think it would take a lot of time. So this is my general dropout regularization architecture. I can surely run this and show this to you.
Hi, Raghav. I'm really sorry. We are going to have to move on, unfortunately. We are a little tight on time because we have so many sessions. Yeah. However, I do know that you have shared the code, right, in our resources. Yeah. So can people go and run this for themselves? Is it in that kind of useful kind of format?
Yes. I believe I have shared my GitHub repo, and the code would be totally available for everyone to check out. I know it was a pretty deep talk to complete in half an hour, but I'm really sorry. No. I hope it was enjoyed. However, we could cover. But sure, reach out to me for any questions, and let's have a good discussion on any of the topic regarding signal processing or sound AI and anything like that. Yep.
Fantastic. Thank you so much. So for everyone, Raghav, if you head over to the chat, people can ask you questions there on the web page. Sure. But we will also have all of the resources at aiconf.education/resources. So do go and find that code and run it for yourself. We've almost left you on a cliffhanger there. Okay, so next up, we are going to jump straight into a panel. We are not going to go for an ad break this time. Live TV is always a dream. Hi, Lee. How are you doing?
I'm good. How are you, Amy?
Yeah, not too bad. Not too bad. We are a good few sessions in at this point, and we've seen so many different things. But this panel coming up, can you give us a brief overview of what this panel is going to be about?
Yeah, definitely. So, you know, the key challenge that's been set to discuss today is, with many teaching resources being available online, you know, really reputable machine learning courses are now available on Udacity, Coursera, and lots of other learning platforms. It's really about, you know, what do you need to learn as a student to become ready for AI and ML? And are university degrees really teaching the right things? And what do I need to become professional? So we've got a great panel of academics, professional authors, and industrialized people to talk about and share their best practice about how they're implementing really great training into their existing university courses, or producing amazing materials on Coursera and Udacity to allow students to learn in both ways. So I'd like to introduce our panel of speakers to everyone here today. If we just start going in a clockwise audience, so Ajit, would you like to introduce yourself?
Oh, hang on 1 second, Lee. We just need all of our panelists to, there we go. Aisha, do we have your video? Could you just turn on your video? Fantastic. There we go. We're all there. Take it away, Lee.
Excellent. Ajit, if you'd like to introduce yourself.
Sure. Thank you, Lee. Can you hear me well?
Yes, Kanya.
Good, good. Yeah. So thank you for inviting me. I'm Ajit Jaukar. I'm the course director of the Oxford University course Artificial Intelligence, Cloud and Edge Computing. And it does pretty much what it says, meaning that it's a full stack AI course. And we cover the whole thing from cloud to edge devices, including also the MLOps space, meaning taking AI models in Docker containers and pushing them to edge devices. This broadly covers what I do at Oxford. Yeah.
Excellent. I'll introduce Aisha next because she's from Oxford as well.
Yeah, hi everyone. I'm the lead AI tutor in the Oxford course. I'm contributing and supporting all the coding sprints of the entire course, entire section of the course, and I mainly teach how to deploy and machine learning modules in a container and on the edge devices.
Thanks, Aisha. So over to Noah. Oh, you're on mute, Noah, sorry.
My name is Noah Gift. I teach at Duke's data science program, MIDS, and also at Northwestern. And most of my focus is around cloud computing, ML ops, DevOps, and I also have created courses for Udacity and Microsoft Azure, and also Coursera. And I'm currently writing a book called Practical ML Ops with O'Reilly.
Excellent. Thank you, Noah. And Ananda.
Hello, everyone. Get to see everybody virtually. I hope you can all hear me fine. I'm a principal teaching fellow in the Department of Computing at Imperial College, and I teach across a range of undergraduate and graduate programs. And I'm come from a slightly more of a systems background, but obviously I've also been involved with getting to grips with AI and ML and helping out with courses in my department as well. Great to see you.
That's excellent. Thank you. So as you can see, everyone, we've got some great speakers on the call with a great variety of experience. So the first question I'd like to open up is, why is ML and AI such a topic for learners at the moment? So Ananda, why do you think it's such a popular topic?
Yeah, thanks, Lee. So currently, I think they've come leaps and bounds in recent years, primarily aided by the improvement in hardware. The speeds of and processing speeds have enormously improved. But the key thing has also been the availability of data. Data science itself has taken off a lot in recent years. And the leaps and bounds in terms of the problems that people have tried to solve recently, we're getting lots of cutting edge things coming. So it's extremely important for people to get into this field. And it's a really exciting time for students and for industry as well.
That's great. So Noah, you've done lots of books around this area. So again, why are you seeing so much interest?
I think part of it is that many people realize this is where the jobs are going to be created, is in machine learning, cloud computing, and AI. And we're really at the early stages. A lot of the stuff that we're looking at, even self-driving cars, they're still at an early stage. And the operationalization appears to be one of the key issues that is going to get solved in the next, let's say, 5 years. And it's really an execution problem. If you look at some of the stuff that's happened with the global pandemic, we have the technology already available to do things like detect whether people are wearing masks or enhance drug discovery. And really, there was an execution problem in that we just weren't able to implement those methodologies. So it feels like there's a huge opportunity for people, and they see this, and that's why they want to get involved in AI and ML.
Excellent. So Ajit, this really brings on a great question to you around how your course is being developed, and it's really being developed to service that need of changing of careers and opportunities in AI and ML, isn't it?
Yes, that is exactly right. And I think that we are in a way we are kind of a mixture, in the sense that we are an academic institution in Oxford, but our course is an industry-facing course. And I think that I would kind of echo the something which Ananda said was about large problems. Yes, so we are looking at things which are fairly large problems, especially around AI. And that's where you have the sort of the vision of a large university, along with the depth of the research we have, along with the interesting, in our case, certainly the very enterprise focus. So that's been the vision of the course. And that's also been kind of the way we work so closely with industry, sort of working on this whole idea of taking things practically, putting them in MLOps, containers, and right up to edge devices. So yeah.
Excellent. So actually, as Ajit said, you're doing lots of things with lots of new different technologies. So how are you finding teaching these latest technologies?
Yes. Yeah, I completely agree with all the speakers. AI and ML is so topical nowadays because also we are using more and more AI in our daily lives, like voice recognition, object detection, in healthcare, in games. But also, I just want to mention here, it is a very complex topic at the same time because it is more than just learning how to code. It has very complicated mathematical algorithms. And here also we need to think about the security aspect. For example, when we look at the IoT devices like Azure Sphere, and when we think of running machine learning models on the edge devices, we should definitely consider about its security. Yes, I agree, it is so topical. At the same time, it is a very complex topic.
Excellent. So this really brings me on to my next question is, what do universities need to do to keep their courses and learning relevant and, more importantly, interesting? So Ananda, what things have you been doing with Imperial to do that?
Yeah. Traditionally, universities were thought of as more keepers of knowledge, but that's not the case anymore. Knowledge is widely available. A lot of people have access to it. So in a way, for us to be able to keep it relevant, it's very important for us to keep the things relevant. So we need to be able to make sure that we engage with industry, bring in some of the industry-facing problems like what Ajit and Aisha were mentioning about the fact that you've got lots of these problems that industries have, and we need to bring that on board, show more real life examples, and in order to motivate the students in the classroom, because our job is to give them a sound understanding of the thing, but at the same time show them how this is being applied, and that kind of gives a good link between learning and actually doing it as well in the real world.
Definitely. And I think, as Aisha said, it's about teaching the fundamentals and then the application of in that scenario based learning, whether it's a capstone project or a group-based project or an individual-based project.
Absolutely, because you want to keep it relevant to the knowledge that they're gaining in the classroom.
Definitely. So Noah, you've got experiences across a number of different scenarios from, US institutions teaching actual classes from undergraduate to masters. What are the key things that you're seeing in terms of, keeping interest in learning?
Yeah, I think that one of the real key issues here is that education is undergoing a transformation, and in particular, the concept of maybe everyone is a tenured faculty member and they have a job for life and they're focused on research, and then there's teaching is less of a priority. I think is really not. It's peaked, and so now what's happening is you see Udacity, Coursera, these edX, these MOOCs. You also see the cloud companies themselves having to create the content because it wasn't happening at the university level. And so really what's happening is there's an emergence of other ways that people can learn the material. So I think the best approach that a university can take is to embrace the wave. It's like a 100-foot wave coming, and if they ride it and they use those platforms, use Coursera, use Udacity, use the cloud content that's coming from, let's say, Microsoft, and integrate it into the curriculum, and also focus not only on the short term, but subscription-based learning for the next 10, 20 years. I think many programs are also realizing that it's not enough to just get a master's degree. You may need to give the student a subscription for the next 20 years, like Netflix, where they're constantly learning the new material. So I think it's a fundamental reorganization of education.
Definitely. And I think, this really brings us again back to what the work we've been doing with Oxford and AGIT around Microsoft Learn, so we've been actually including Microsoft Learn modules within the courses to make that practical element. So they're teaching the fundamentals and foundations. So AGIT, how have you found, blending this learning approach?
Yeah, so I think that for me, the most important thing, because like I said, we are a very unique course, we're a very complex course because we are covering such a lot of depth within a relatively short time, about 4 months. Yes. So for us, the bigger thing is what I call as cognitive dependencies and cognitive overload. Yes. So cognitive dependencies, meaning that once you start a new concept, you must be sure that something else which has preceded it has also been covered. Otherwise, you lose people at that. And then there is cognitive overload, meaning that you're introducing too many new things in a very short time. And the classic AI is that situation. So we found the experience with Learn to be very useful in that sense, because that allows allowed us to bring a whole bunch of new things, which sometimes we may not have thought, but we can point to people that this is where they need to look into it, and also specifically driving around scenarios, which is extremely useful from our point of view, because what that then anchors the sort of the abstract to the physical, and then brings a very narrow chunk of segment of learning. Yes, because you start something, you end something. A scenario had a start and an end, and there is result. Yes, so I think this is how we see this whole kind of blending of learning, and it is new for everybody, including us, because we've not had to do this online until the start of COVID. And since the start of COVID, I have run 3 fairly large courses online, which is a dramatic shift. And in that sense, it's a great thing for us to sort of accelerate the learning in that sense.
Excellent. So, the whole COVID situation is impacted everyone around the globe. Aisha, as a tutor on the course, what sort of things have you had to change in the way you're tutoring the course?
Sorry, can I get the question again?
Yeah, so, have you had to change the way you work with students now, moving to a remote basis?
Yes. Actually, my main role is to teach the concept of the edge and the concept of the machine learning on the device. So by using the Microsoft Learn modules, I'm giving the students a big picture about the edge computing, IoT, and machine learning, how to run the machine learning on the devices theoretically. But then after the session, the students take a Microsoft Learn modules and they have a practical experience by going to models and running them themselves. So this is really good for us, to use the Microsoft Learn module, so students gain practical experience with that.
Excellent. So, I think we all agree there's a huge opportunity for both students doing like vocational learning and using courses like Udacity and Coursera, and doing the fundamentals with the capstone projects, practicals and labs. Is there any key materials or learning that you think students should have within those courses? What are the key areas that students today should be thinking about looking at? So first to Noah.
Yeah, I think one of the things that is really a change is that, because my background is really from industry, and in industry, you have to create a product. And if you're working as a mobile developer, typically every week you need to have a new release of the mobile app, or a web developer, you need to have a new release. I feel like if you're able to teach people to create demos and portfolios, and that's for me, that's the courses I create. The outcome is you have a GitHub profile, you have a YouTube video, and you show that you have demonstrated mastery of, let's say, Azure ML Studio, or a computer vision project, or a data engineering project. I think that's one of the key differences that I'm pushing students for, is that there's a very specific outcome, and it's not just theory, which theory is very important, but there's an artifact that's permanent that someone can take with them for the rest of their career.
Definitely. And, you actually shared one of those with me yesterday, so last night. And for me, that's amazing to see when, I can see a student and they've got a GitHub repo and they've got a great video on the YouTube of how they've done that project and what they've worked on it. And again, we've been doing very similar things with both Ananda and with Ajit around capstone projects. So, that's like my biggest, compliment to students is when you do things, showcase what you do, because that is your CV and portfolio material. There's thousands of students today doing a machine learning AI class, but what makes you different to a potential employer like Microsoft, or even within the institution? So for me, it's portfolio piece. Having a demonstratable piece that is a GitHub repo and a video is awesome. So Ananda, in terms of those experiences in the courses, what sort of extra things do you advise students to do?
Yeah, so what we try to do is we sometimes get alumni involved as well, just to kind of see that we get their experience, to see when they were in the classroom, was there something that they felt that they missed? And it's a good learning experience because they kind of bring in their experience and then they tell their students, you know what, in the first year, second year, I was advised this, I didn't quite do it, but actually this is a good idea. So, sometimes, sometimes listen to your teachers. It's a good thing.
Yeah, and then,
so alumni bring in a really nice field in terms of advising students. So we try to hold industry-specific talks. We've had Microsoft as one of our partners on the talks, as you know. So they kind of bring in experiences from that, and they are able to tell and engage with the students to say, as you're learning, as Noah mentioned, there are certain things that you can build your profile on as you're part of your learning, so that when it comes to applying or when it comes to showing off, you're not panicking and then trying to reactively try to do all these. You've actually proactively done your portfolio, proactively kept track of stuff, proactively kept up to date with what's happening. So then it's automatic. So when you're ready, your stuff is ready to be shown to anybody you'd like to show it. So it's very important to involve industry and alumni to kind of advise students, because they are the ones who are seeing CVs and they're on the other side after graduation.
Definitely. And I think, from Agent's perspective, I noticed on your course you have lots of well-reputable guest speakers and presenters. So again, is that a key thing for you in terms of building that engagement with students to get them interested in these areas?
Yes, so there's two sides to this. I mean, other than what everybody else has said about having a portfolio and stuff like that. So the first thing for us, it's about a hard problem. Yes, so this is very important, because today, if you just do a regression or classification and put it online, I guess just about everybody is doing that. Yes. So in Oxford specifically, so this morning we had a talk with Paul Clark, who is the CTO of Ocado, and he's an amazing person in the depth of his experience in sort of robotics and how the future in mobility and autonomous vehicles, etc. So from our point of view, we expose people to the really hard problems, because we are Oxford in that sense, and we try to get people thinking beyond just the code or just the hardware, just the software or something like this. This is all about putting all those things together to solve really big problems. So we are pretty much an engineering-led course, and this is what we mean by that. So we are looking at solving hard, complex problems within the engineering field. And this is, I think, what would distinguish a lot of people going forward, because to me, the bar has shifted to a much higher level now. Yes, so I mean, even 2 years, 3 years ago, people were doing sort of simple stuff on GitHub and getting kind of noticed. Today, if you do a CNN, just about, everybody can do a CNN, and
there's super tools like Lobe AI, which you can just build a machine learning model in 2 minutes.
Exactly. So the bar has risen, and this is what I was trying to emphasize.
That's a great example, and I think we've got some, you're all from amazing institutions around the globe, and we've got callers from all around the world on this call. So what advice could you give to a student who doesn't go to one of the top Ivy League or Russell Group universities? And is there a great way or a good way for them to get the same education online? So Noah, I think this has to go to you first of all.
Yeah, I do think that, it's a little, the question is a little bit like saying, is a Mercedes a good car? And it's like, of course. Or is a Tesla a good car? It's like, if you can afford it, great. But at the same time, I think there are also probably many other ways that have, there's other cars that are also great cars, right? That are not as expensive. So it's the same thing where I think you can get incredible content directly from Microsoft. I mean, you can go to, like you said, Microsoft Learn, and you can get equivalent material. And in particular, I think part of it is that it's the portfolio is the key. And I think that this was mentioned just briefly, the hard problem plus the portfolio. You can do the same thing. And so if you're able to get access to the best material, and there's lots of resources now, and that's probably the biggest change in the last maybe 10 years is that, and I think another person mentioned this, is that it used to be locked away at the university. It's not locked away anymore. And so I do think every single, 1 billion people on Earth could do the same thing that you're doing at any university, as long as you're creating that artifact, the artifact of your portfolio, and you're comparing yourself in a realistic way to other people, so that you're creating something that's comparable or better.
Excellent. So Aisha, you're still a tutor. You're still learning. So as someone who is probably the youngest person on this call, what do you do to keep knowledgeable and up to date on technology? Because you're trying to teach it, support it, and provide amazing advice to students.
Yes. My first advice would be, if the person is getting started to learn the machine learning and AI, I can recommend that they need to make sure that they understand the basic of the computer language programming that they are using. So for that computer language language programming, for that language, I would recommend the Python. So then once you have done with the Python, it is you can move into the machine learning. And if you ask me where to start to learn machine learning, I can say start from the basic algorithms like linear regression, KNN, SVM, because they are fundamentals and they're important to understand how things work. And then once you are done with the learning, the algorithms, then you can go and you can practice them in the online platform. Like it could be Coursera, could be Microsoft Learn. I checked the Microsoft Learn, for example. You are using these machine learning algorithms in different modules, so you can have practice. You can do the practice as well.
Excellent. So just coming up to like wrapping this up. So really, I just want some top tips from each of you around how students can get started on learning AI and ML and feel confident in building that amazing portfolio. So Ananda.
Yeah, I think I'd like to echo what Noah and Aisha have just said. Extremely good advice from both of them. Material, lots available. What is key is to get a good understanding of that material and understand the theory behind it. And most importantly, get your hands dirty by trying things out and learning by doing. Because it's all about saying, oh, I put a few libraries together and I've done this. But do you understand behind it? What happens if you change things? And that's the level of understanding that they need to have. And for that, you learn by doing. You need to take the theory, understand it, and learn by doing it.
Excellent. So, AJ?
Okay, so top tips, just very briefly, there are two things. First of all, I would like to say that the university courses, including us, surprisingly enough, as an offshoot of COVID, are available worldwide, which is very unusual. Until about 6 months ago, you had to come to Oxford physically, and we've had people from Australia do that as well. But it is good that it is available online. The second point is a bit of a contrarian advice to somebody who wants to come into AI, and a tip which I personally give to a lot of people. I think the AI world is still skewed towards a few areas, mostly financial services and things like that. Yes. So in my view, there is a bigger world out there, which is not yet touched. Perhaps a little bit of healthcare people are doing, but the engineering, the oil and gas, and everything like this. Yes, there are all these bigger companies, industries, which are not even touched by any of these things. Yes. And I think there is a huge opportunity there, because in my mind, AI will touch, and this is why in Oxford, we look at Azure Sphere, we look at those, Aisha mentioned about the security, or we are looking at 5G, again with Microsoft working with some of those areas. And I think those are the areas we see that there will be huge growth potential going forward in AI.
Excellent. So Noah.
Yeah, I think that one thing that people can do that is again, the online courses are great material, and in addition, what are the other things that you can do to make yourself look different than the competition? And one of the ways is certification, and this is something that is a lot of times is just neglected. Is someone says, oh, I have the material or I have the degree, but it's actually not that much more effort to just go to let's say, get the Azure Associate Data Scientist certification, which is really a machine learning engineering certification. Is you're checking the box that's going to allow you to get that next position. And then likewise with the portfolio, by creating that portfolio piece that's really shows exactly what you've done, and especially if you can create several different types of portfolio pieces. So maybe you do something with computer vision, maybe you do something for data engineering, you do something for ML ops, and then you also get the certification. I think those really are the things that are the basics that a lot of people don't do. And it's very easy to separate yourself from the pack because you did the things that other people wouldn't do. There's that expression, right, that says you do today what what others can't because previously you did what they wouldn't, you know, or something like that.
So yeah, I would like to just say a huge thank you to all our speakers. You know, Noah touched on it there about certification and accreditation. And I think, you know, that's a real key point, is to make yourself stand out above the crowd now. It's not just having a degree or a college certificate, it's also having that professional certification and that experience. So a huge thanks to everyone. And again, I'd like just to pass this back to Dimitri. I know he might have just one more question, but over to you, Dimitri.
Thank you, Lee. That was really a great panel. It was so nice to hear the advice like learn Python and learn the basics of algorithms, because that's exactly what we started this conference from the basics of machine learning algorithms. I think just one more point is that going to university, of course, brings you also the environment, like people, friends, and those kind of things, which you cannot get online. But otherwise, it just requires a little bit more efforts from you, and you can get the same great education just by yourself. So we are living in a great world now. Thank you, Lee, again for putting this panel.
Thank you.
Thank you. Thank you, everyone.
Thank you. Bye-bye. Bye. Thank you, Lee. Thanks. Bye.
Let's run a short commercial and then proceed with our program. Hello, everyone, again, and thank you for staying with us for this long. It's getting quite late, I think, for those who started this conference in the morning. But Alexia, who is our next speaker, she joins us. For her, it's quite early morning. Alexia is the founder of Resilient Pathways. She's communications consultant, and she has the personal story of AI not treating her right, not being fair. So she will open this block of talks on responsible AI, on privacy and related issues. So over to you, Alexia. Can you maybe shortly give a short introduction and then proceed with your talk?
Hello, my name's Alexia Georgiou. I'm in Knoxville, Tennessee in the USA. I have 25 years with ethics in the mental health field. I was a privacy officer for one company that I worked for. And bias, I have specific training through my studies at the university and bachelor's and master's degree in social work and counseling, respectively. So the one medical ethic is do no harm. And how can we apply that to AI? Our outline today, I'm going to tell my story. We're going to identify what is artificial intelligence and the story it tells. Facial recognition, how it's being used. Fairness, the gadgets, and some resources. Okay, so I went to a country 7 years ago and I was joining a tour. And I like to travel independently, so I bought my plane ticket to arrive early and leave after the tour and visit another country before I came home. So it was a 3-week trip. And as I was leaving alone, I walk in the airport and I had traveled light because when I travel independently, I take public transport. So here I was with my backpack and a small roll away luggage. So it was probably half the size of what you normally see someone carry. And all of a sudden, 5 military police surrounded me. They questioned me for 20 minutes. The questioning was about traveling light. Why did I only have one sweater? What was the weather like where I was going next? And we kind of were going in circles. I was very afraid, but I wasn't showing emotion because I knew if I reacted, then they might put me in handcuffs and take me somewhere further. And then finally, one of the men looks at me straight in the eyes and he says, "Do you not understand? We think you're going to blow up the plane." So at that point, I almost laughed in his face, but again, very constrained with my emotions. And they let me go my way. So I'm going through security, and it was just interesting that I had this nail file. I had flown to this country from the US through Europe with this nail file, and now it was a problem. So they lectured me, took the nail file, and let me get on the plane. The next country I go to, I enjoyed a week relaxing. As I'm about to leave, I wanted to get something that's fresh in that country that you can't find elsewhere to eat for lunch on the plane. And so here I go, walk in the store with my backpack and small rollaway luggage. And they said, "We would like to look through your luggage," when I was paying. And I said, "No, you won't, because you have not seen me do anything. I haven't opened anything." And so there was my privilege right there. And I walked out and went to the airport and flew away. So if you have been treated suspiciously, I would like for you to put in the chat yes. And we will be taking questions from the chat. If we run out of time, I will be personally going through the chat afterwards and interacting with you. So what are the facts? We always need to look at facts. I traveled to another country and I was profiled as a terrorist. I have no criminal record. I was leaving the airport alone with light luggage for a 3-week trip. And my family is from a country that has conflict with the country I visited. The only way they would have known that is profiling me through facial recognition, because I had not even reached the counter. Now, you may be asking, what country is this? It doesn't matter what country. This is happening in every country. And the country that I live in, I am not treated suspiciously. I'm a white woman. And what would my life be like if I was treated suspiciously in my own country? So I have a taste of what it's like, but I do not know what it's like every day. And many people live like this. So what is artificial intelligence and the story it tells? In 2016, Google's AlphaGo played the best players. This was AI playing the best players in the world of the game of Go. This is an ancient Chinese game. This is the world's most complex game, and this is how we learn strategy. And so when the game of Go not only beat the best players in the world, but also came up with original moves that nobody for centuries had come up with, the world turned their head and said, wow, you know, there's something going on with artificial intelligence. So AI works best with big data, and we know that. So we are the data, we are the code. And everything that we're typing in the internet, and we're very relaxed on social media, and we're connecting socially with one another. We're sharing our photos, we're sharing openly, and social media now is using us and searching us. A lot of our data is being sold, and that's without our consent. And so we thought that we were using social media and searching it. And what we're learning, and one documentary that talks about this, is the social dilemma. When something is free, we are the product and not the customer. We also learned in a recent Senate hearing in the USA that one of the social media giants is tracking users across the internet. And this is only beginning to be talked about in our government because there are no laws. And that's why it's so important to talk about ethics, and for companies like Microsoft is doing to be proactive and to make the ethics of AI a priority and to be intentional about it. And so during this Senate hearing, The senators were meeting with CEOs from 2 of the top social media giants here in the USA. And at the end, they said, okay, this is like the Wild West. You've done whatever you wanted to do. We haven't regulated, and we need to work out a plan. And one of the things that was identified is that users on this one platform are being tracked across the internet. Now, I'm going and using this platform. Why are you tracking me across the internet? Everything, all the emails I'm sending, the private correspondence. So that's what AI is collecting: our thoughts, our desires, our dreams, our private thoughts. AI knows who our friends are. So everything is valuable. All data is valuable, from what we post, that we post, how we post. So is it see you later, or is it see you at 6:30 tonight? I'm looking forward to our dinner. So this is contributing to our predicted value. AI is deciding who we are. AI is using the information to tell the story of us. Have you noticed the ads are more specifically targeting us? An example, due to the pandemic shutdown, I was on the internet online a lot more. My eyes started getting strained, and all of a sudden, I'm seeing these ads targeting me for eyeglass frames. Well, I thought, yeah, I need to have my eyes checked. I had my eyes checked, and I ended up buying these glasses. So these glasses, when I first looked at them, were a certain price. But when I put in what's the price for progressive lenses, the price went up. And so then on the social media targeting ads, I would see that the price also changed for these pair of glasses. So that was very specific targeting. Have you noticed when you go on any site on the internet that there are recommendations? So if we're following a streaming service to watch something, recommendations, and that it's nudging us to follow. So it's really important to keep that choice. We have a choice and we have a voice. Okay, emotional contagion, it's something that's studied in psychology. Have you noticed that your emotions are affected by other people? Specifically, if someone is in charge of a meeting, and the way that they're speaking definitely affects the group. So pay attention to that, because digital emotional contagion is also very contagious. In a study, Facebook manipulated which posts showed up on the news feeds of 600,000 users for a week. The results: people were more likely to use positive words in Facebook posts if they had been exposed to fewer negative posts throughout the week. So we definitely are influenced emotionally by our interaction online. Okay, so facial recognition. In China, citizens in certain parts of China are paying with facial recognition. Also, I saw a photo of a cart on the street, and it was a Kentucky Fried Chicken cart, and people were walking up, paying with facial recognition and just taking what they wanted. So facial recognition is defined as the technology capable of verifying or identifying a person from a digital image or video footage from a video source. Now, how does facial recognition have our data? We're giving AI our data through every single photo that we have posted online or shared. And so companies are mining these photos and selling them. So they are selling them to law enforcement, federal agencies, and private companies. One such company is Clearview AI. Now, this definitely is helping law enforcement to identify people. And so, for example, in the US, we're getting a lot of packages. We are now ordering more and more. And if the package is left on the front porch, people are finding that the packages sometimes are stolen. And we still don't have every citizen here in the database because you'll see their face on the news. This person was caught stealing. Here's the video footage. If you can identify them, let us know. Or people, they'll rob a pharmacy, and the news here will, again, post their face and say we're not sure who they are. And so about 50% of the citizens have their photo in the FBI database, and that's one statistic that I recently read. So you may say, okay, I didn't give permission for these photos to be sold, and I was just sharing them to my family and friends on social media. How do I opt out? The laws. In the USA, only in 2 states can we opt out, Illinois and California. So in Tennessee, I cannot opt out. So it's my responsibility to go to the state of Tennessee and say, we need laws for the ability to opt out. Countries of Canada, the EU, UK, Switzerland, and Australia. Again, only those countries have laws that allow us to go to the specific database and say, I would like to opt out. Now, this is per photo. Can you imagine tracking every single photo that you have put on social media and saying, I want to opt out? So to be removed, the first step is providing a headshot and photo of your government issue ID. So there we're giving them very personal and specific information. Okay, let's talk about bias in facial recognition. If you are a white middle-aged man, you are easily identifiable by this system. Likelihood to be misidentified. Asian and Black people are 100 times more likely to be misidentified. If you're a woman, elderly, or a child, you are more likely to be misidentified than a white man. Okay, so there was a USA drugstore, and Reuters started doing a report. And since Reuters did the report, the drugstore pulled the facial recognition. They use facial recognition in 200 stores across the USA. They targeted lower income and non-white areas. So the impoverished areas were 3 times more likely to have this tech in their stores than more wealthy areas. The purpose was to defer theft and protect staff from customer violence. So this drugstore matched facial images of customers in their store to those who were previously in the store observed engaging in potential criminal activity. So these citizens hadn't done anything wrong previously. They weren't currently doing anything wrong. An alert was sent to a security agent's smartphone. It was matched for accuracy, as this is the same person that visited our store previously. And then that security agent would ask the customer to leave. Okay, this was not based on facts. This was racist. And why am I saying that? Let's look at the statistics. Shoplifting in the USA. 11% of our population shoplifts. More men than women. Blacks, Hispanics, and Asians have lower odds than whites to shoplift. It's more common in college-educated and US-born, more common in single-person incomes of $35,000 and more, and family incomes of $70,000 and more. And those with public insurance are less likely to shoplift. So this is why I'm saying the drugstore based their actions on racism and not facts, because if they were targeting people according to the facts, they would be targeting the white men, college-educated, US-born, who make good incomes. There's a candy experiment. Wealthy people remove twice as much candy marked for children than people of more modest means. Now, this was candy for children. And so adults shouldn't even touch it. And so this was quite disturbing. It was in 2012. Why? There's a hypothesis. This could be possibly why. Lower income population, they're less likely to cheat and steal. They're more invested in their communities, and they fear being publicly humiliated because they probably will be publicly humiliated more so if they're caught in the act of stealing than a wealthy white man. The wealthy have more entitlement, they're self-interested, and they have no fear of authority. And so I have projected that image when I was in that other country, and I said, no, you're not going to search my luggage. I honestly didn't have time, and I walked out. That was tremendous privilege that I was able to do that. Okay, so we want to bring fairness and talk about the importance on how we can be intentional. Word embedding. Researchers looked at an AI tool called word embedding that's transforming the way computers interpret speech and text. They found words like female and woman were closely associated with arts and humanities. Male and man were closely associated with math and engineering. Okay, so there was a sequence. Man is to woman as father is to mother. Man is to woman as king is to queen. Man is to computer programmer as woman is to homemaker. This was from Google News. It was written by journalists. And this is the language that we pulled out. And it should say man is to computer programmer as woman is to computer programmer. So the bias is in us, and we are feeding AI data. Open source language, everyone can change. So when you hear these words or see them, be the one who speaks up and say it doesn't sound right. Master, slave, whitelist, blacklist. What are some of the gadgets that are being used? Drones have the ability of long distance monitoring, automated identification, automated tracking. They're cheap and have broad and large scale reach. So cameras are all around, and drones that we can't even see, like even miles away, have capability. There's a specific camera that can be affixed to drones, 30 times optical, 6 times digital zoom, 180 times magnification. It can move and adjust its view thousands of feet to several miles away. So we are being watched. How much are we being watched? This is a map of the USA. These are drones that can be equipped with this kind of camera used by local police departments. So this for me is very shocking to see how much we have in our country. What's available for private citizens to buy? There's a Ring mailbox sensor that will notify you if your mailbox has been open or closed. It works with the Wi-Fi. It's $30. Doorbell cameras are as cheap as $40. The Ring Always Home Cam is something new. It's a drone with a camera in the home, $250. And the robot dog. Now you are getting links to everything referenced in this talk, and you will be able to see the robot dog. It was filmed by a Canadian citizen at night in a residential area. It recently went on sale, and so the eyes are flashing of the dog. It's just taking photos. And some people were very afraid. Others thought it was cute, and it went very viral on Twitter. And so you'll be able to watch that video. This is military-grade technology available now for sale to private citizens, $74,500. I wanted to focus on doorbell cameras. There's a Neighbors Public Safety Service. It's in USA local police departments, and they have information sharing partnerships with Ring. It's a kind of doorbell camera. So we're not necessarily giving consent. And this is, again, a map of the US. The red is fire departments that are actually accessing private citizens' doorbell cameras, and the blue is police departments. So when I zoomed in on my city of Knoxville, Tennessee, our police departments are using, accessing private citizens' doorbell cameras. So anytime we're walking in our neighborhoods, driving, we're being potentially watched. And why is that important? Because I mean, if something happened and I call the police and I say this time of day at this address, sure, they can look that up and catch the criminal, even zoom in on their license plate with video from one of my neighbors if they have these cameras. However, what is the protection that a law enforcement officer or someone at the fire department won't abuse this and just start watching? Because we are a society, we're curious about each other, and just look at the reality TV and how popular that is. We like to look into other people's lives. So what kind of accountability is there? That's the question that I have to ask. So what are resources? Tools and Weapons, The Promise and the Peril of the Digital Age. It was co-authored by the president of Microsoft, Brad Smith, and Carol Ann Brown. The foreword is by Bill Gates. Also, Microsoft has excellent AI principles. Again, you will get the link to look at Microsoft being intentional about the ethics. So fairness, AI systems should treat all people fairly. Well, we're not treating people fairly in society, and we are the data. And so how do we reconcile that? Reliability and safety. AI systems should perform reliably and safely. Privacy and security. AI systems should be secure and respect privacy. Safety is physical as well as psychological safety. Inclusiveness. AI systems should empower everyone and engage people. Transparency. AI systems should be understandable. So many people do not understand what AI is. And that's a reason that I created this training. As a common citizen, I took a Coursera class called AI for Everyone, and I started really following and studying what's happening, because this is our future and every citizen needs to understand this. Accountability. People should be accountable for AI systems. Every company needs AI principles and an AI ethics officer. So I want to thank you. And we have about 4 minutes if there are some questions in the chat that we could answer.
Oh, that was fantastic. Thank you so much, Alexia. That was brilliant. Goodness me, so many facts, right? So many interesting stories you shared there. If we have people in the audience, I can imagine they're similar to me and they're just sitting there taking it all in for a minute. However, I would like to ask you a little bit about some of your top learning materials. You mentioned you'd been on some online courses. What would you recommend as the next step for everyone in the audience?
So the next step in the resources is specifically to look at the open source, because anyone in the technology field can begin flagging the words and the terms, and to begin challenging it wherever they are and creating change. It's up to us to be the voice and to take action. We can't wait for someone else to do it.
Yeah, I love that. I love that idea that once you're watching these things or reading books, you mentioned the Tools and Weapons book with Brad Smith and Caroline. Yeah, I've not actually had a chance to read that one. That one needs to get on the bookshelf very soon. I'll be on Amazon later. And yeah, and like once you start taking some of that in, I think you see these things a little bit more. I think sometimes if you don't necessarily know things are happening, or you're not, you know what, like none of us get it right all the time, do we? And so actually being able to have that trigger where you go, oh, I've read something about this. We covered the FATE framework, the fairness, accountability, transparency, and ethics very briefly at the start. And one of the things was kind of just this set of questions that was, you know, we should ask ourselves about this when creating AI solutions. A lot of our students on the call will be quite new to AI. Is there any advice you have for them to build unbiased or fair AI?
So AI is new to all of us. Even Google had to be trained. So the instructor on the AI course that I took, he actually trained Google. Even though you think, oh, Google, you know, they know. So yeah, I mean, it's new for all of us. so if I can study it, I think everybody can study it and just learn and watch the news, because articles are coming out and it's not being carried by mainstream media so much, but so much is happening during this time that we're not realizing. So I'm giving a whole page of links that gives just plenty to read about. And honestly, if I can understand it, I'm not a technical person. I tried to take an applied AI course to build a chatbots for my website, and I had to back away because the language is completely different and I couldn't comprehend it. So if someone like me with a social science background can understand AI, anybody can understand AI. Yeah.
Love that. Well, thank you so much, Alexia, for your time. We are at the hour now, and so we are going to keep on this theme with our next speaker. But Alexia, thank you for sharing all that data, all that insight. It's been an absolute privilege to have you.
Thank you. Thank you very much, Amy.
Okay, just a quick one before we move on to the next session. We just wanted to call out the Cloud Skills Challenge. So if you go to aka.ms/AI/challenge, it's just at the bottom of the screen just here, and you'll be able to go and take a look. You can win a goodie bag of swag if you rank in our top 10 of our leaderboard, and we've got about 40 people so far signed up, which is great, and 3 have completed some of the modules. So do get in there, start looking at what's available. You do have a full week though to complete this, so no rush. Do continue to pay attention in some of our sessions. Okay, that's for some of our announcements. Up next, we are staying on the same topic, and we're going to be talking about teaching your models to play fair with Rishit. So Rishit, are you there? Could you turn on your camera for us? Fantastic. Hi, how are you doing?
Hi, I'm doing good.
Good stuff, good stuff. Rishit, can you introduce yourself very briefly?
Okay, sure. So I have a slide for it and I'll cover it now. That's
no problem, no problem. Let's hand it over to you then. I can see you're sharing your screen, so we'll get that up on the stream now for you. And yeah, feel free to take it away.
Thank you. Thank you for having me. And I'll start right away. Okay. So hi everyone. As Amy said, I'm Rishit, and I'll be talking about teaching your models to play fair. So how you can ensure fairness in your machine learning applications is what I'll be talking about today. And we'll also have some cool demos at the end, which you can try out for yourself too. So stay tuned till the very end. So I'll start first off, before I move any further, let me tell you that I'll try to take questions. So if you have any questions, feel free to put them in the chat. And I'll try to take questions if I have enough time at the end. If not, I'll try to answer them in the chat after the talk in the chat itself. So a bit about me. So I'm a high school student from India. I'm a TEDx and TEDx speaker, and I love to speak at conferences like these. Thanks for having me. I also love hackathons and competitions and have represented my country in quite a few of them and even won them. I also love research and have published multiple research papers on AI and mathematics. Feel free to check them out if that's what you're interested in. And to know more about me or connect with me, here are my coordinates at rishit.tech. So feel free to go on this website and know more about me. So that's about me. Let's get to the talk now. So before I even start off with what we are going to do about today, I would like to point out who the ideal audience would be for this talk. It would essentially be AI developers who have worked on making any kind of models. So if you have made a TensorFlow model, if you have made a scikit-learn model or a PyTorch model earlier, this talk is for you. You will be able to make sense. And it would also be AI developers who are looking for ways to build fairer and inclusive and more inclusive applications. So that is who the ideal audience would be for this talk. So just a bit about what we are up to today. We'll start off with the idea of responsible AI and Then we'll go on a bit about what is fairness. The speaker, the talk just before me covered a bit about fairness. So I'll tell you a couple of things from the modeling perspectives about what fairness means to you and why you should care about this. Because, well, I could have spent 30 minutes learning a new modeling strategy, but why should I be caring about fairness is also what I'll be telling you. Then we'll also take a look at Fairlearn and finally go on to see some live demos. So let me start with the idea of responsible AI. So the development of AI is creating new opportunities to improve the lives of people all around the world, from business to healthcare to education. AI is revolutionizing almost every industry out there. I do not need to talk much about it. So at the same time, it is also raising new questions about best ways to build fairness, to build models which have fairness, which are interpretable, which take care of privacy and security into these systems. And there's a lot to it. For this talk, we'll be discussing about a part of responsible AI practices, or the 4 major principles of responsible AI practices, as I like to call it, which is fairness. So that is what we'll be discussing for this talk. So let's start with what is the idea behind fairness all about. So at this stage, I like to explain it. You might be aware of the meaning of the word fair and can make a pretty good guess about what it means in the machine learning context. So instead of telling you any definition kind of stuff, let's take an example and see it through. So what I want you to do is, in your mind, I want you all to think of a rose. I'll give you a moment to do that. So what did you think? And most of you out there would have most probably thought about a red colored rose, which is the most common one. I also thought about the red colored rose myself. But some of you might have also thought of a white colored rose. Again, this also classifies as a rose. And I guess no one might have thought of a blue or a blue shade rose. So I hope you are trying. I hope you are making some sense of the idea of fairness in the machine learning context. Let's take another example, a short one now. So I want you all to think of a pizza. So what did you think? Most of us thought about this, including me, a triangular slice of pizza, but well, this classifies as a pizza too, a rectangular shaped one. That classifies as a pizza too. So by now you might have got a fair enough idea of what I'm talking about. So with that, let me tell you a bit about what a fair algorithm is, or how you can say an algorithm is fair. So in these examples, you just saw that you are giving much importance to a particular kind of object based on maybe color, shape, or some other property, which is called bias. So what I want is, so on the slide right over here, it's written that property of a person does not affect the outcome. I want you to think of it with a minor edit over here, which is sensitive properties of a person should not affect the outcome. So if you have a voice recognition system, which does not detect, let's say, women voices and only detects men voices, or is only able to correctly understand men voices, that's bad. And you probably have a bias in your model. So your AI model should also not favor, let's say, a particular race of people or discriminate based on skin color and so on. Protected attributes or protected property is what I like to call them. So so as of now, I want you to understand a fair algorithm according to these two points which I've mentioned right over here. So it's a common misconception I've come across. I've come across this a lot, that since AI systems are based on mathematical algorithms and statistical models, it would be neutral or fair. And I hope you might have thought about this. You might have thought about this at a stage yourself, that, well, under the hood, AI is just maths, statistics, mathematical algorithms. So it would be neutral or fair. But you could essentially also have data which is biased due to the way it is collected. Or maybe the model itself could introduce unfairness. Or you could have the deployment process introduce some bias. So what's the motivation behind all of this? How important it is to actually talk about bias? So again, the analogy where you could have learned, you could have spent 30 minutes on learning some new kind of modeling technique, why you should be attending this talk and learning about fairness. I'm sure you all know about GPT-3. It's pretty trending topic now. All of you, I'm pretty sure you know about GPT-3. And it was trained on over 100 billion parameters, performs so well on multiple tasks, but still faces bias. It is so in this tweet, a person mentions how the GPT-3 is biased for Muslims. And this is indeed a huge problem. Even after being trained on billions of parameters, performing so well on other problems, it still faces bias. And this is a huge problem. It is discriminating Muslims, as showed in this tweet. Or take translate, for example. It automatically classifies professions to gender-based pronouns. So she's a nurse, he's a scientist, whereas the original sentences were indeed gender neutral. So this is also an example of how important fairness is in production level applications. And people have also started to realize how important this is, especially in production applications. Just a cool little stat showing the number of research papers in a year about fairness in ML. A lot of work being done in this field. So in 2011, there were just 11 or so papers a year about fairness in machine learning. And going back to 2017, I actually took this stat. So going back to 2017, a lot of research papers about fairness in ML, people have started to realize how important ML is for production applications. So let's see how we can improve our models or allow them to play fair. So first off, worth a mention that fairness in AI is both a social and technical challenge. Data could be biased due to social problems. So we'll see on such a tool called FairLearn to help us introduce fairness in applications. And you'll also see how easy it is to do so with FairLearn. So also note, FairLearn is experimental, and a few things I say here, a few of the syntax I mentioned, the demos or which I say here, is vulnerable to change. So a part about FairLearn I love the most. So I'm talking a bit about FairLearn now and how you can start introducing fairness in your models. So part about FairLearn I love the most is the ease of assessing and mitigating biases with a dashboard. So you could assess your model fairness from multiple features within a FairLearn dashboard. One way to start evaluating the fairness for a model, as shown in the slide right over here, is to compare predictions for each group with a sensitive feature. So here I have included age to be a sensitive feature, which is just an example. You could have something else too. So we could split the data into subsets for each age group and compare the selection rate for each of these groups very easily with the FairLearn dashboards. So some groups may be overrepresented in the training data, or the data may be skewed so that cases within a specific group aren't representative of the overall population which you have, leading to this bias. Or the sensitive feature itself may not be predictive of a label. And there are a lot of reasons, a million reasons due to which this could be happening. This or you could also compare various models very easily. So what I can also do with FAIRlearn is, well, I talked about how you can assess fairness of your models with FAIRlearn. So I also want to talk a bit about the mitigation dashboards. So I can very easily compare multiple models on some metric like accuracy and fairness and disparity very easily with FAIRlearn dashboards. You'll soon see how you can build these dashboards for your model and how you can improve your model. So let's talk a bit about this. As at the end of the day, what I want to do is mitigate fairness into my model. So again, FAIRlearn helps you to do so. It's not just limited to assessing fairness in your models. So you have a couple of mitigation strategies with FAIRlearn that you can use, again, with the FAIRlearn dashboard. So as of now, FAIRlearn has these couple of mitigation strategies. And a common approach to mitigation is to use one of the algorithms and constraints to train multiple models, and then compare the performance, selection rate, and disparity matrix to find the optimal model for our needs. So I'll compare multiple models based on performance, a disparity, and selection rate metrics and find out the best model I need. So with FAIRlearn, you have a couple of mitigation, has a few algorithms for mitigating fairness in your applications. So for the scope of this talk, since I'm time bound, I'll not be going into details of how each and every algorithm here works, but you can know that these can very easily be used with FAIRlearn, as we'll be seeing in the demos. These models also support different fairness definitions. So as an example, the threshold optimizer right over here does not support error rate parity and so on. But yeah, I'll not go into detail about each of these algorithms right over here. So let's see an example of using the grid search algorithm, and let's see a sample example of it. Again, it's super easy to use mitigation strategies. And let's say I'm running a logistic regression algorithm and specified demographic parity, which is one of the most well-known, famous criterion for fairness. So what does the demographic parity mean? It essentially says that the difference between the groups getting the positive outcome should be 0. So if I have 2 or 3 groups, the difference between the group between all of these groups which get the positive outcome by the model should be 0. That's simply what the demographic parity means. And let's understand how easy it is to take a look at, make multiple models with FAIRlearn and check out the best model for yourself. So first off, I'm saying it is a logistic regression algorithm. So this could be anything. It could be a TensorFlow model too. But for simplicity, and for this talk, I've taken a simple logistic regression model from scikit-learn. I'll then specify demographic parity. As I said, it is one of the most well-known criterion, and which is and on that constraint we'll be measuring our fairness. And as the name suggests, we then do a grid search, make multiple models, see the stats and the trade-off between accuracy or any other metric with a fairness metric. So as of here, I have the disparity in predictions as a fairness metric, and I compare it with the model accuracy. So I can then take a pretty good look at the models which FAIRlearn has made for me, and choose the right model. We take a look at how you can choose the right model, compare these models in the demos. But yeah, it's really good to know that you can very easily do this. And this was possible with just a few lines of code. So that is, again, I feel pretty cool. You'll soon see this in action too. Another great part is that FAIRLEARN is integrated into Azure Machine Learning. So you can build these dashboards right in your Jupyter notebook with the results of your model. Or what you could also do is, now you have a fairness tab in Azure ML currently in preview. So for every run you do with Azure ML, you could see the fairness dashboards and how to mitigate them. The feature is also available within Azure ML once you register your trained model with it. So you can run an experiment in which the dashboard metrics are uploaded to your Azure Machine Learning workspace. What this allows you to do is then enables you to share the dashboard in Azure Machine Learning Studio so that your data science team can track and compare disparity metrics for models registered in the workspace. So makes the whole process a lot more easier, allows you to build shareable dashboards very easily. So that is also something I love with FAIRLEARN. So with that, enough talking, and let's get to the demos part. And this is a link for the demos. It essentially redirects you to a GitHub repository, and this link is also present in the resources section. So you can take a look at the link from the resources section, or quickly make a note of the link right now from the screen. So it's bit.ly/FAIRLEARN-demos. So with that, let me quickly switch to my demo screen. Okay, so hang on with me for a moment. I'm switching to my demo screen. And here it is. Okay. Okay, so I hope you can see my demo screen now. And this is a GitHub repository, which I talked about, has a couple of examples for you, allows you to understand more about fairness and these demos itself. So today we'll be taking a look at one of these demos. And just before the session itself, I have run this demo. So I wanted to execute this live, but doing the grid search takes up a pretty long time. So I executed all of these just before the session, so we can take a look at the outputs right now. So I'm taking the census data which we have. Okay. I hope it is better visible now. Forgot to zoom in. So I'm simply loading the census data. I'll perform a couple of data transformations. So in this tutorial, what we'll be seeing is, I want to see if a person has their income greater than 50,000 or less than 50,000. So, and I want my protected feature or protected attribute to be 6. So that is what I'm doing over here, and just performing a couple of data transformations right over here. Nothing great over here too. Splitting the data into training and test sets. If you have worked with creating ML models, you most probably know how all of this works out with scikit-learn. And again, I'll be showing you code on how to do it with scikit-learn with a simple logistic regression algorithm. So you can very easily replicate this on your own machines too. But be aware that you can most certainly use a TensorFlow model in its place too. So first off, I want to load this predictor into a fairness dashboard and examine how unfair my model is. So this is a simple model. It has no idea about fairness, or as I like to call it, it's an unmitigated or original model. So I load it into the fairness dashboard, FAIRLEARN dashboard. Since I'm at the dashboard part, I also wanted to tell you, as of now, FAIRLEARN dashboards are only available in Jupyter notebooks. So I'm using a Jupyter notebook right over here. If you try to run this in Colab or Jupyter Lab or some other Jupyter-based environment, you wouldn't be able to run these fail-on dashboards. So just a note, I wanted you to be aware about it. Okay, so let's go in, and the fail-on dashboard tells me to set up my assessment. I need to complete 2 steps. So let's see what those 2 steps are. First off, it wants me to specify the sensitive features. As I said, I just want to I want to take the sensitive feature as 6. So let's just select that, click on next. And I now have a couple of metrics on which I can calculate the model. So as of now, just selecting simple accuracy, the fraction, which is the fraction of data points which are classified correctly. So I'll just select that for now, but this may very well vary with your business use case you are trying to solve. So as an example, for a medical use case, you would most probably want less number of false positives. So that all of that would vary with your business use case. So first off, I see disparity in performance or disparity in accuracy. And I see 83.8% is my model accuracy. Well, I did not want to train a model with very high accuracy. It's just a demo. So yeah, I have a model with 84% accuracy. I can see the accuracy for male class. The accuracy for male class is 79.5%. And I can see the accuracy for female class, which is 92%. I can also see the under prediction and over prediction rates for the male and the female class. And the difference between both of these accuracies of the male class and the female class, so 92.4 minus 29.4, which is 12.9, is the disparity in accuracy. So I also see disparity in predictions, which is essentially the selection rate. And I see that 23.1% of the males had their income above 50,000, and 7.5% of the females had their income above 50,000. So calculating the disparity in the selection rate, I have a 15.5% disparity in the selection rate. So this is not a very great a disparity which I have. So I'll try to improve it now. So this is essentially the part where it takes up a lot of time building multiple models. So this is where we are doing the simple grid search, which was also there in the slides. I'll make multiple models with it, and I'll go, and there's just some simple code right over here, allows me to format my data, and I'll go to the dashboard now. So again, I have 2 steps. Let's see what those 2 steps are. They're again same. The sensitive feature, let's select 6. We are doing on that. I'll select accuracy again. I already mentioned why I would do that. And here I have it. Fairlone created all of these models for me with just a few lines of code. I don't need to do a lot of things. So my unmitigated model is over here. It is at almost 84% accuracy, but has a disparity in predictions of about 15%. So you can, according to your business use case, you can take a look at all of these models. I most probably might go with this model right over here. So let's click on it to know more about it. And I see that the overall accuracy of this model is 78.4%. I've lost a bit on the accuracy, but let's see the disparity in selections, and it's 0.5% disparity in selections. So I went from 15% to 0.5%, and I got a bit of lower accuracy, which may be acceptable to me. So I think, so this is what we just mitigated with Fairlone. And you can also see all of this right in Azure ML. So since I'm running out of time, I'll not show the grid search part in Azure ML itself. But yeah, you can also see multiple models that Phelan creates for you in Azure ML2. So with that, let me quickly switch my screen.
Yeah, excellent. Thank you so much, Rishit, for a great presentation. I don't think time for questions. I just wanted to mention that FairLearn works pretty well with the models with features, right? So it's like tabular data or something like that. But the fairness problem also lies when we want to train, for example, on the images, right? And it's not that easy to detect disparities and imbalanced data sets when we have images and we want to solve, for example, image classification problems. So FairLearn is a really great tool, but it's only just the beginning to consider the problem of fairness in AI models.
Yeah, I feel that's true. There's a lot more to do. And one of the things which I also truly believe is this is not just a technical challenge which we can solve. It's a societal plus technical challenge. So we have to do work from both the aspects.
Exactly. And it's great that there is a lot of discussion nowadays around that. So thank you again. And I would like to welcome our next speaker, Nigama. So Nigama will tell us about how to train object detection models on TensorFlow. She is a student from India and machine learning engineer at aiconf startup. Hello, Nigama. I think you are muted.
Hello, can you hear me now?
Yes, now we can hear you.
Okay,
So yeah, you can start sharing your screen and you can start with your talk.
Okay, great. Just a second. Are you able to look at my screen?
Yeah, we can see it.
Okay. Hello, everyone. Thank you so much for joining the session. I'm Nigama. Before we start, a little bit about myself. I'm a sophomore student studying in India. I also work part-time as a machine learning engineer in an early stage startup called aiconf. So today I'm going to be talking about how object detection works, how to build an object detection model, and I'll also discuss a use case of object detection that I worked on, which is a sign language detection model using TensorFlow. I'll walk you through my approach of building the model, how I used transfer learning and all of this stuff. And then finally, I'll discuss about how I'm planning to improve this model so that it can be used by people in real time. So yeah, let's get started. First up, a little bit about object detection. Object detection basically involves picking a bounding box around the object of interest in some images. And object detection is used almost everywhere these days. It is used to detect humans. It is used to detect things and objects. And even when a Tesla car is driving by itself on the road, it detects objects around it, and that is how it is able to move through the space. So yeah, I just wanted to say that object detection has become a very powerful tool lately. So if we want to build an object detection model, there are some basic deep learning concepts that we need to understand first. We need to understand how CNNs work. We need to understand how RCNNs work. We also need to know how to use the popular TensorFlow object detection API. So let's start with understanding CNNs, which stand for convolutional neural network. To start with, when you're working with a CNN, you have some input data. You're going to do some convolutions, and that generally is just creating feature maps, and we'll talk about those in just a little bit. And then we do some pooling. Usually it is called max pooling, and I will also explain about this too later on. And each of these you do is going to be a hidden layer. And then generally you will add one fully connected layer, which would also be a hidden layer as well. And finally, you have your output. So fully connected layer is usually something that takes the end result from a convolution and pooling and comes to a classification decision. So it is basically connected to the output layer. So when you do a convolution, this is generally any form of mapping or creating a feature map from an original data set. And what this is going to involve is just going to be this moving region or this moving window over your image that is looking for something or is going to create a feature out of a window of pixels. So sometimes you might have this searching through an image, looking for either horizontal or vertical lines or edges and so on. And therefore you use a library such as OpenCV for this purpose. To visualize this, let's take an image. Let's assume we have an image of a cat and it is divided into pixels. So whenever we pass this image as an input into the CNN, it is broken down into small pixels like this. So each of these squares is a pixel. And for example, if we do a 3x3 convolution, we might start with a window which looks like this. And this new window is going to pretend as a new cell. And then we shift that 2 spots over. And this continues until the window slides over each and every pixel of the image. So now we move this window down to the left. So the 3x3 convolution is over here. And finally, the last 3x3 convolution will be over here. So this process continues until it doesn't skip any pixels from our input. And that is how convolution works. And of course, this is a very simplified version of how it works. So if this is convolution, then what is pooling? Let's say you've done all this convolution and it has just produced some values for us. So again, we created these new kind of boxes or each of these new kind of regions from the image, and they might actually have values in them like 2, 3, 4, 1, and so on. So let's say this is our new feature map with values, and now what we're going to do is we're going to do some pooling. Again, to keep it simple, let's do a 3x3 pooling. So when we pool, it is a little bit different from when we created the feature map. When we created the feature map, we created what pooling is actually going to do for us, but we kind of also extracted those values. Now, when we're taking a 3x3 pooling, it is usually called max pooling, and this is because we are looking for a maximum value in this particular window, and that maximum value here is a 4, right? So when we shift it over the next, and then we have this box, and then the maximum value over here is a 3, and then we come down, the maximum value is a 4, and then here again, and the maximum value here is a 3. So again, this is an extremely simplified version of what pooling does, but that is kind of the idea behind it. So this convolution and pooling together gives us what is called a hidden layer. And you will usually have 2 or more hidden layers. And then finally, it is connected to a fully connected layer, which is basically something that collects the output from the hidden layers. And then we have our final output. So this is the idea behind how CNNs work. So now we know for a fact that convolutional neural networks can help us in identifying images, right? So, but the real world is much more complex than images, right? So when we humans look at our surroundings, we can identify what objects are present around us in a matter of seconds. So not only our mind can identify them, but also we can see how different one object is from the other. Now the question is, can convolutional neural networks do this task? The answer is yes. And the way they do that is, let's say we take an already existing convolutional net, like VG16, and we want to kind of repurpose it for object detection. But how do we do that? So basically, to achieve that, we take an existing classifier or an existing architecture like InceptionNet or VG16 and other architectures, and we take our image that we want to give as an input. And let's say we want to detect for any, just a second. Let's say we want to detect for a motorcycle in this image. Now, the pre-trained models can obviously detect a motorcycle in this image because these are huge neural networks that has been trained on tons and tons of data set. So now what we can do is sort of take this pre-trained model and slide it over our target image. And if you remember how CNNs work from what we discussed earlier, when we pass the classifier through every window of that image, it is going to classify as many objects as possible from that image. So we basically end up with a huge number of classifications, amongst which our target object, that is a motorcycle, is one of them. So there has to be a better way of doing this. Instead of going through each and every window, we have to have a better approach for this. And that better approach was proposed very recently, and that method is called RCNNs. Now, what RCNNs do is, instead of working on a massive number of regions, the RCNN algorithms proposes a bunch of boxes in the image and checks if any of these boxes contain any object. And RCNN uses something called selective search to extract these boxes from an image. So basically, in selective search, there are various regions from an object, and it classifies the images based on features like colors, textures, enclosures, and so on. And when these patterns or features are identified, it proposes various regions from the image. So let's say this is, it takes this image as an input. Then it generates initial subsegmentations so that we have multiple regions from an image like this one. And then this technique, this selective search technique, combines all of these similar regions based on these different features that we talked about, and it forms a larger region and finally produce object locations. So this is how RCNNs are different from CNNs. Now, coming back to utilizing these models, why do we concentrate on using TensorFlow particularly? The reason why this is so kind of useful or powerful is detecting things in images is something that has been existed for a very long time. But detecting objects in images that you could stream kind of like on a video, and to detect things at 15 to 20 frames per second, and especially if you want it with a decent accuracy. Now, that was a big challenge. And to write the code from scratch by yourself that is going to do all of this for you would just take forever. So this TensorFlow API does most of the work for us, since they already have large number of pre-trained models. Now, I want to share a use case that I worked on, which is a sign language detection model to basically improve my understanding of building deep learning models. So the main objective of this was to use the TensorFlow object detection API and train the dataset to detect these different images and convert them into text. And I specifically focused on American Sign Language because they have a really active online forum, which was really important for me to derive the dataset from. Before that, I want to talk a bit about sign language processing. So there is a misconception about sign language that there exists only one form of sign language, and that is not true. Every country has its own form of sign language, like German Sign Language, British Sign Language, and so on. And yeah, it basically depends on the geographical location, right? So here I started out with a goal to translate the entire sign language, and it was actually a bit much, and I had to narrow down my scope and really focus on a few different signs at a time. Like, for example, I trained my model on signs which represent basic signs such as hello, yes, no, and yeah, so I basically concentrated only on these basic signs. And so, like most machine learning and deep learning systems, we start with collecting the dataset. I initially thought I would just use the data that is available on the internet from online forums or Kaggle, but I was not really satisfied with the results that I got. So I decided to make my own dataset with the help of OpenCV, Label Image, and Python. And then after data collection, we do some pre-processing, feature extraction, and finally we get a real-time system. And as discussed earlier, I focused using CNNs for pre-processing and feature extraction, and specifically some transfer learning as well. Since I'm using my own dataset, to use that dataset, it was very limiting to use that in a real-time system. So how does this all work together is, first up, we use our own webcam to collect images that we are going to use to train on. And those images are then going to be passed to Label Image, and we start drawing detection boxes against these different sign language poses. And once that is done, we can use transfer learning against the TensorFlow object detection API to be able to train on an object detector. And the last step is to use Python and OpenCV to detect those different sign language poses. And OpenCV really makes it simple with its video capture object. So it basically connects to your webcam and lets you read in frame by frame and apply whatever the operations that you need. And ideally, what we end up with is a real-time object detection device that uses your webcam to identify these different sign language poses. Now, I did talk about transfer learning earlier. I want to talk a bit more about it. I think it is one of the most powerful ideas in deep learning. And this is because sometimes you take the knowledge that a neural network has learned before from one task and apply that knowledge to a different task. So for example, a neural network has learned to recognize a cat or a dog. We can use the power of that knowledge and apply to our own models, our custom models. And for example, architectures like MobileNet SSD, which is a predefined model, which is also offered by TensorFlow, is used as the base and this fine-tuned It is also fine-tuned to improve the accuracy and the range of the objects that can be detected. And this model can be trained for any custom object that is required by the user to keep track of that particular object. So now, the ultimate goal of this project was to develop a real-time sign language detection application that will be accessible for everyone, but the existing video conferencing apps like Skype or Zoom or Teams only detect speakers by voice activation. So it is really a challenge to identify if someone is signing at any given moment. And this is the reason I wanted to develop an application that is fast and still reliable. So to improve this further, we can, I had this option to basically convert this model into a TensorFlow JS format to run in the browser. Now, TensorFlow JS model is again basically a JavaScript library for training and deploying machine learning models on the browser and also on Node.js. But why would someone want to run their object detection model locally on their browser, right? So the idea of doing it locally in the browser is that you can get a lot higher speed so that you can do it in real time instead of having to wait for those API calls to go through and stuff like that. And it is also the kind of the concept of AI on edge versus AI on cloud. So when we convert that model into a TF.js friendly format, we can then use that to make real-time detections using React.js and our webcam and our own webcam. And finally, we can also visualize these real-time detections on the screen. And now you have your own model which can identify various sign language poses. Now, the cool thing about this is you can use this exact same format and the code that you used here and apply it on any other use case that you want. Like if you want to detect vehicles, if you want to detect stop signs, for example, and a whole heap of other applications as well. So yeah, I will leave a link for my GitHub repo on the resources page. I'll make sure other links are updated as well so that you can read and build your own object detection models. So yeah, that's all about it. Hope you learned something from my session. Thank you so much for listening, guys.
That was great, Nagama. Thank you so much for sharing. What an amazing project that you worked on there. Thank you. Yeah, really interesting. We do have a couple of questions for you. So the first one is from our audience. So let me just, here we go. So which object detection model is fastest in your experience? YOLO, RCNNs. Have you compared different models for sign language detection?
Yes, so personally, I think YOLO is very recent, and I think it was proposed like in 2015. I don't know, I'm not sure, but I think that's the more advanced one after RCNNs. Yeah, because YOLO, the concept of YOLO is basically you only look once. It only looks once at an image, and it can basically classify it. So I think YOLO is the best one to go for.
Fantastic. Good advice. Good advice. And there's a follow-on question from that. So how many object classes did you train for?
In what context?
So I think you have lots of different words from the sign language. Was there a certain amount of classes that you were looking for in your transfer learning, or was it something broader than that?
Yeah, I was just concentrating on fewer words, fewer phrases, like not alphabets particularly, but phrases of words like hello, total words.
Great.
I basically pass them into label image and mention them as hello, I love you, or other phrases like that. Yeah.
That's cool.
I trained only on five phrases, I guess. Yeah, because I wanted to keep it accurate and I wanted to be accurate. So
yeah.
Yeah.
Yeah, no, that's really interesting. I guess these kinds of models, as you're training and experimenting with them, if you start with the smaller amount of classes and then gradually add to them, and hopefully start to see scale. But if you start to lose accuracy, obviously that can happen if you have a lot of different classes or classes that are quite similar. You spot that rather than just throwing them all in there. So that's a really, really cool approach. I have a question for you, actually. You explained CNNs and RCNNs really very succinctly, very well, very efficiently. Where did you learn about CNNs, the theory of it? Did you learn that for yourself? Was that on your course that you're on?
Yeah, so everything that I learned about AI or coding, everything was off of internet, from YouTube and all those resources. I didn't take any courses, so everything was off of internet. So yeah.
That's fantastic. I mean, congratulations. That's really, really impressive. And you just kind of went out and found them. There is so much out there, isn't there? We heard from a career panel, should you go to university or not to learn AI and deep learning? And that kept coming up, that it was theory is good to make sure you go understand. And a lot of things are now available online for everyone to take advantage of. So it's great to hear that you use them. You, what do you mind me asking? What's your background? Because you've done a really broad project there. Like, I feel like you epitomize the word data scientist, because you were like, I had to go and research that it was ASL that I was looking at, and I needed the forum of people to get their insight and their advice, and then the pre-processing, and then finally the machine learning model, and also where you were going to put it. You mentioned all the different types of models, whether it was on the device or in the cloud, etc. Was that just different parts that you learned yourself, or did you work with a team?
No, I did not work with a team. This was just my project that I started like 2 months ago. It was just for me to understand how deep learning models work, how I can implement them. So this was one idea that I implemented amongst many. So yeah.
Love that. Well, congratulations. It's an incredibly interesting project. You're getting lots of praise in the chat, so do go to the website and check that out as well. People are really enjoying the project that you just explained. And if you have any resources, we will put them onto the resources tab for you, so that we can share them. That's great stuff. So just before you go, actually, what would you recommend as everyone's next step here to maybe build something similar?
So I wouldn't say everyone to build exactly what I built. I would suggest everyone to have a goal in mind, the end goal, what you want, the product, what you want to create, and kind of work backwards. Like, after you learn all the basics and all of that stuff, there is a very high chance that someone else already has your idea and they have already made it. So search for it, dig the internet, and work your way backwards to building your product. Yeah.
Fantastic. Thank you so much for your time, Nagana. It is an absolute pleasure to have you on and talk about object detection. No problem. Using TensorFlow. For those out there who haven't used TensorFlow before, you can also do object detection in Azure Custom Vision, which brings us nicely onto our next topic. Before that, I just want to reiterate that we have our Cloud Skills Challenge available. So if you go to aka.ms/AI/challenge, you will be able to go ahead and take part in that. You have the opportunity to win a swag bag if you become part of the top leaderboard, and you also remember you have a full week to complete those modules. So get signed up today, work on them for the rest of the week as we go towards the middle to the end of December. Okay, so we are on to our last two sessions. It's so great to have everyone continue to watch. Do keep bringing those questions into the chat so that we can talk with our different speakers and you can really dig into the projects that they are working on. But without further ado, let's introduce Loxley. Hi Loxley, how are you doing?
I'm doing great. How about you?
Very good, very good. I think it's early where you are and getting late where I am. So thank you so much for joining us on your early Saturday morning.
Yes, no problem.
We are very excited for your next talk because you are going to also be talking about things like classification and object detection, but using the Azure Custom Vision. And you have a bit of a story there. I won't ruin it, but I will say, let's go over to you. Do introduce yourself. We'd love to know a bit about you as well, but we'll let you take it away.
Awesome. Let me grab my slides really quickly, hit present. So hello, my name is Loxley Kolakowski. I'm a senior studying informatics at the University of Washington, and I'm giving my talk from the greater Seattle area this weekend. It's currently 8 o'clock in the morning. So my past experience includes internships at Microsoft and Accenture, and I'm currently interning at an AI startup called SiteWorks. And I also am the hackathon director for the Women in Informatics organization at the University of Washington. And my talk, Anyone Can AI with Azure Custom Vision, is for beginners who want to learn more about the AI solutions that Azure offers. But as I was making my talk, I thought that there may be a better name out there, such as an unexpected lesson in ornithology. And so you probably didn't expect to get a lesson in birds this weekend, but I guarantee you'll have some interesting technical and bird fun facts to share with your peers on Monday. But I'm first going to start out by giving a brief overview of what is custom vision and how I personally learned about it. And so I've had the amazing opportunity to participate in hackathons all across the United States, but no matter where I went, the winning teams were always deploying intelligent AI solutions. And whether that was smart glasses that could read a book out loud to the visually impaired, or a tool that could detect Parkinson's disease, these students were changing the world with AI. And what I quickly learned is that Azure was making it really easy for students to create these. Instead of education level being the barrier here, the only limit to what could be created was your imagination. And that is where the Anyone Can AI comes from. You don't need a PhD in machine learning to create your first working model. And so Microsoft Azure has solutions for all types of machine learning. But what I'll be focusing on in this talk is Custom Vision, Azure's image and object detection service. And as an extra bonus, it's low code, and for our demo, almost no code. So there is no skill barrier here either. So let's first cover how custom vision works. So since this is a talk for beginners, I'm going to give a quick primer to what artificial intelligence is in the context of custom vision. And so there are 5 distinct parts to any machine learning algorithm. The first is inputting the data. And so artificial intelligence is not inherently intelligent. We first have to feed it data and tell it what it should be looking for. And so a good use case to consider here is a self-driving car. We first have to collect data on like red lights, yellow lights, and green lights, and label them so the computer knows which image is which. So the second up we have is analyzing the data. So after inputting the data, it is then analyzed by the computer. And so the data sets we will be working with today are relatively small, but you can imagine if an algorithm had thousands of images it had to analyze, this would be an incredibly time-consuming process. So next up is finding patterns. At this point, the computer has gone through each of the tags for images. And if we go back to our traffic lights example, it has probably realized that all of the photos tagged with the red light has the color red in it, and likewise for the yellow and green light images. And so next up we have is making predictions. And so after determining a pattern, the computer now knows that future data that follows the same pattern should also be labeled similarly. And so, for example, the next time a red light is fed to the computer, it knows it is a red light and hopefully tells the car to stop. And last but not least is storing feedback. So this is the part where Azure Custom Vision and AI are just absolutely brilliant. After we have inputted the data, it'll begin training itself on the rest of the data it is then fed. And so over time, this will increase in intelligence and become a more accurate model. And so in short, data comes in, patterns are determined, and predictions come out that can be validated for accuracy by yourself. And for demo today, we're going to do it on hummingbirds, specifically hummingbirds that are local to the Washington state area. And this is just a really fun fact I learned while creating this talk, but hummingbirds are only native to North and South America. And so we have 4 main hummingbirds in the Washington state area. We first have the calliope, which has these frayed red neck feathers. We have the black-chinned, which is uniquely purple in color. We have the Anna's hummingbird that also has the red neck feathers, but they extend to the head. And finally, we have the Rufous hummingbird, which has kind of like these greenish gold neck feathers. And disclaimer, although I'm a Washington state native, I have never seen any of these hummingbirds before in my life other than the Anna's hummingbird. And supposedly that is the only one that lives in Washington state year-round. And the great thing about all of these hummingbirds is that they're all relatively different from each other, so it should be no trouble for custom vision to tell the difference between them. So now let's hop to our demo and see how that goes. And so here we are in Custom Vision, and at this point I've already logged into my Custom Vision account, created a new project, gave it a name, and connected it to an Azure resource. And so for our demo today, we'll be focusing on image classification, where each image can only have one label. And so Custom Vision has domains for common use cases such as food, retail, and landmarks. But since hummingbirds don't really fall into any of those categories, we're using the general domain to train our images today. And so now, here we are in Custom Vision, but we're about to embark on the most time-consuming part of creating a machine learning model, and that is the data labeling. So to do that, we're just going to quickly hop into Bing and save the first 5 images we see of an Anna's hummingbird. Save image as into this file that I've already created. Save 1, 2, and then I'm skipping over this one because I'm not 100% sure that it is an Anna's hummingbird. Save image as 3, 4, almost done with this step, and 5. And at this point, we're going to go back into Custom Vision and add these images to our model.
Loxley, I'm sorry, I think you are sharing maybe the wrong screen because we're not seeing what you are doing.
Oh,
just
thank you.
Yeah.
Okay, awesome. Let me quickly hop in. Sorry about that. I'm going to stop sharing again and then share again. Okay, is that good?
Yes.
Awesome, thank you so much. So at this point, we've added the images into Custom Vision and we're going to give them the tag Anna. And then we're going to upload these 5 files. And so Custom Vision needs about 20 images for each model. And so we've already, for the sake of time, I've already collected images of all of our other models. And at this point, we're going to hit train. And so there's 2 different types of training that Custom Vision offers. They offer a quick training and an advanced training version. For this one, we're going to choose quick training, but for more complex data sets, it's recommended to choose the advanced training option, even though it'll take a little longer to run. And so we're going to hit train here. And I've seen that it's taken about 5 minutes for these to train. And so for the sake of time, I've created an identical version of this, which has already been trained. And here we're going to run a quick test on it very quickly. And so we can browse local files, find test, grab a black-chinned hummingbird, and then it comes back as being 99.9% likely, so it's correct so far. Browse the local files again, grab the rufous hummingbird, also coming back 99.8% likely that it's a rufous hummingbird. And now I'm a little concerned about our calliope and annas because they're the most similar hummingbirds of this batch. But the calliope is coming back 100% certain, and let's try with an anna's hummingbird. Try it with this one, also coming back 99% certain that it's an anna's hummingbird. But there's one last thing I wanted to test really quickly. And so let's try with this hummingbird, which I've intentionally labeled as a rufous. And it's currently saying that it's a black-chinned hummingbird. And so like, why could that be? So I know that I always make data labeling errors when I'm working with custom vision, but I made this mistake intentionally. And the thing that I realized when I was first creating this demo is that this is an example of a female rufous hummingbird, and only male hummingbirds have the kind of metallic feathers on their neck. And so basically, what I realized is like these were the examples of all of the female hummingbirds. So here we have the calliope, here we have the black-chinned, here we have the annas, and here we have the rufous hummingbird. And so basically the calliope, black-chinned, and annas are practically identical. And although this was accidental on my part, I unintentionally left out over 50% of all of these hummingbird species, which brings us to the main point I learned when first experimenting with custom vision. First is we need more data, more photos of hummingbirds to make our model accurate. And number two, we need to be mindful about how we're being inclusive when creating these custom vision models. And the great thing is that these two pieces go hand in hand. By adding more photos and practicing inclusivity while we do, our model would become more accurate of all the hummingbirds we say that we're representing. And so that was fun, but I think we have time for another demo. I wanted to give custom vision an even greater challenge. Could it tell the difference between a crow and a raven? And so in Washington State, we've had a very interesting phenomenon occur in the last decade. So a couple years ago, crows started popping up like all over the greater Seattle area. And what we learned is that they roost at a wetland near the University of Washington's Bothell campus, and then they fly out in the morning and then return there in the evening. And it has gotten to the point where there's practically a crow strutting around on like every single block in the entire city. And so we know that Washington State has crows because they're smaller and have a pointier beak. But I went to Yellowstone National Park last spring and they had ravens, and you could tell because they have these more fluffier feathers around their neck and a more robust beak. And so let's see if custom vision can tell these apart. And so here we are in custom vision again. I've created a second model specifically for crows, and I've already saved all of our crow images. Go into crow vision, crow. I'm going to open these. Then we're going to add the crow tag. Usually takes a couple seconds to load these massive, like a whole bunch of high definition images into custom vision. And now it also, a cool thing is it tells us when we ever accidentally add a duplicate image. So now we've added in our crow images, and so now let's add in our raven images. Add images, go into crow vision, Raven, and now we're going to add our Raven images. We're going to give them the Raven tag and then upload these 24 files. And once again, we're going to hit train on this, click the quick training option, and then select train. And once again, I tested this and it takes approximately 5 minutes, and I've already created an identical version of this that has already been tested. But before we run a quick test again, I wanted to draw your attention to these 3 main circles, and like what they mean and why they're important. So these circles are visualizations of how accurate our model is. So the first is precision, which determines how likely our model will be correct when it detects a tag. And so next up is recall, which is percentage of tags that it has predicted correctly. And the final tag we are looking at is AP, which determines the accuracy of our model at different probability thresholds, which you can change and adjust the probability threshold up here. And so I have found that a good rule of thumb is to have a precision above 90%. And if it isn't, I usually add more images, test it again, and then wait until it has hit the 90% precision threshold. And so now let's quick test with this one and see how it goes. I'm going to go into our test folder, add in a crow image, and it comes back as being 100% certain that it is a crow. So it's correct so far. Let's try with a second crow image. It comes back as 99.9% certain. Perfect. Now we are going to try it with a raven this time. Coming back 100% certain, and we have one more raven I wanted to try. And now this one is our first kind of mistake we've come across in our custom vision model, is it's coming back as 77.8% certain that it is a crow. And when I come back and look at this closer, we can see that our precision for the crow is 100%, but comparatively our precision with the raven is only at 83.3%. So, which we should probably add more data to improve the quality of this model, which ultimately comes back to our point of the importance of having more data and practicing inclusivity. So now that we've seen that custom vision can tell the difference between lots of different types of data that are even very similar to each other, but what is the use case for this? How can we share what we've created with other people? And so for this, we're going to create a very simple static web app with our custom vision model and a tool called Azure Functions. And so Azure Functions is Microsoft's serverless compute resource. And what makes serverless really cool is, unlike a typical compute resource, it only runs when we trigger it. And since it isn't running 24/7, it is really eco-friendly and cost-effective. So to first make this work, we're going to go back into custom vision, go into our bird vision model, and the first thing we're going to make sure is that our model has been published. And after doing that, we're going to hop into settings. And so in the settings tab, we'll see all of the information we need to create an Azure function. And so I've already taken this information and used Visual Studio Code to write and deploy a function to the Azure portal. So I wanted to quickly highlight a few key pieces here in the Azure portal. So the first thing are these 3 lines, which is pretty much like after publishing our tab, it gives us these settings to the end key, which gives us access to the custom vision service. And then the second thing I wanted to specifically highlight is this kind of our logic, which probably looks relatively familiar. We're basically running an if-else function where if it detects either an Anna's tag, a Blackchin tag, Calliope, or Rufus, it'll return the following message. And so we can test this out really quickly with this test run service. And so basically how this is currently working is this is the type of serverless function, which is called an HTTP request, because when we submit an HTTP request to the server by changing the URL, the serverless function is triggered and sends back a response. So let's test this out really quickly. What we're going to do is we're going to add a parameter here, and we're going to give it the name URL, and then we're going to find an image of a hummingbird and copy its URL, its image link. We'll enter this here, and then we will take out the body, and then we'll hit run. And then our quick test does that this accurately came back as a Calliope hummingbird. So this is currently working really well within the Azure portal. Let's try to do it in a static web app now. And to do that, we're going to get function URL and copy this following code. And now we're in our static web app. And the first thing it tells us is an image URL is required. And so to make this work, we're going to use the following syntax. We're first going to add a question mark, URL, and then equals sign. And then we're going to copy and paste an image of a hummingbird, copy image link, and paste it in. Hit enter. Our serverless function has just been triggered, and it returns back, this is a Calliope hummingbird. And so let's try it again with a Rufus hummingbird this time. Rufus hummingbird, I like this photo, copy image link, everything. And now at this point, we've already added our question mark, the URL, and equal sign. So we'll be changing everything after the equal sign. We'll enter in the Rufus hummingbird. The serverless function is triggered and it returns back, this is a Rufus hummingbird. And so now let's try again with the black-chinned. We'll try, let's see, I like this one, copy image link. And once again, we're changing everything after the equals sign. This is a black-chinned hummingbird. And finally, we'll test it one more time with an Anna's hummingbird. Copy image link, change this equal sign right here. And it returns back, this is an Anna's hummingbird. And so here we have it. We have a static web app that could be accessed by anyone in the entire world right now, which is just super cool. So now let's go back to our PowerPoint. And so basically at this point, like the next steps I have to take is to flesh out the website so it's a little easier for someone to interact with, so they don't have to actually manually adjust the URL to make the serverless function trigger. But hopefully that will be the next talk. And so in conclusion, I hope that you see that the only limit to Azure Custom Vision's power is your imagination. I hope you see that birds are only the beginning to what Custom Vision is capable of. And so my question and call to action to you is, what will you build? And finally, whatever awesome thing you create, I would love to see it. Tag me on Twitter with what you create. And before we end, I wanted to direct you to some great resources that have personally helped me learn these technologies. So the first is just Custom Vision AI, so you can test it out yourself. The second is a Microsoft Learn module where you can learn to create a model that classifies images very similar to what we created today. Second up is a Microsoft Learn module that can help you learn how to detect objects within Custom Vision. And then finally, I have a link to the Seasons of Serverless Challenge by Microsoft, which is how, if you're interested in Custom Vision, serverless, and Azure functions and combining them all together, it's a really great challenge to be participating in right now. And so thank you so much for coming to my talk, and I hope that you learned something new about the awesome world of Azure and AI today. Thank you.
Thank you so much, Loxley. That was really a cool talk, and you managed to pack so much into 30 minutes, including Azure functions. That was, I mean, amazing. There is one question we have in the chat. So somebody is interested what happens if we give custom image the image which contains no birds or no hummingbirds, like what would be predicted for such an image?
Man, that's such a good question. And I feel like that's just me. I have to add more data to the custom vision model. Like, oh man, I want to test that so much right now to see, like, if I just added a random image, what would it say? I'm guessing it would just not detect any tag in the image right now. But if I added more images of like, hey, this is not a bird, this is a completely different species of bird, I think that would add a little more to it. But if I were to guess right now that if I tested with just a completely random image, it would just come back like no tags detected. And so how that would affect like in serverless, not 100% sure.
Yeah, I think you are correct. I think we did those experiments, and if it contains nothing really similar to the bird, it just gives 0 probabilities to all classes, which means that it's not purely a classification model. It's a classification model which can also have the class for no detected objects. So there is an interesting question. I think you mentioned that there is no limit to custom vision, but custom vision is really easy to use. But in some cases, you still prefer to train your own model. Like, for example, in the previous talk by Nigama, she showed us how to train TensorFlow model, which is a more complex task. So do you think there is like the pros and cons for using custom vision or training your own models?
Yeah, man. That's also such a good question. I feel like one thing I've seen with custom vision is with that, I think maybe would be a beneficial by creating your own model is, man, I'm trying to think how to exactly phrase it, but I've noticed as I've personally used it, it's like once you get to a certain point, as I was once creating a model like last February where I was adding in like every single letter in the alphabet, and suddenly you're dealing with like thousands of images. And I feel like something like that could be automated in TensorFlow to be significantly easier to create. But that's just my current like feeling is like maybe in the more like simple things, it makes more sense. Or maybe if you only have like 10 tags, but once you get into like maybe a self-driving car where you have to detect thousands of different things on the road in real time, suddenly using it might not be the best option in the world, and there might be a more like, yeah, TensorFlow would be make more sense in the situation.
Yeah, actually, one point here is that you can automate custom vision. Because it has an API. So if you want to upload like many objects, instead of doing it manually, you can do it also programmatically. But custom vision, technically, it contains the machine learning transfer model behind it. So there is a pre-trained neural network and then some classifier trained on top of it, which is like a very clever way to do it. But it is not like the original neural network, the CNN, is not being retrained fully with custom vision. So it means that for typical objects, it would work like very nicely. Like in the custom vision, when you start your model, it asks you, what are you going to classify, food or like general objects? And there are a few options. So for those kind of options, it works pretty well. If you have some very specific objects, like, I don't know, some tools or something which is not common, then it might not work as good as your own TensorFlow model. So there is still value in training your own models, even though it's much more difficult. In my experience, I mean, I've done some projects with object detection and with object classification, and we always started with custom vision. Like we trained our first model with custom vision. We saw like how much accuracy we can achieve, and then to improve it, we retrained our own model. And typically, it was a little bit better, but not significantly better. Also, custom vision, you showed us that it can work through as a web service, right? But there are cases when you might want to run it locally. Can you run custom vision models locally, or is it only like a web service?
I'm fairly certain you can run them locally, but I'd have to do more experimentation with that. Even the first time, it's actually, I think the first time I've ever deployed it to an actual like public website was like for this talk. And so everything I've done previously has been completely local to my computer and just using it within like the custom vision portal. And so I think it's definitely possible, but that's like more experimentation on my part to figure out how to implement that specifically.
Yeah, that's an important thing to I think to remember, that cognitive services, we all often use them as a web service, but in fact, most of the cognitive services can be also deployed in containers locally. So the fact that that you need sometimes the local model should not stop you from using custom vision. And also, by the way, custom vision has a great feature. If you train you can select the mobile version of the network. Like when you start your project, you can say, I want to train the mobile version, in which case you can download the actual model from custom vision and use it locally on the mobile device. So it's really, custom vision is really such a cool tool indeed. So yeah, thanks a lot for sharing this. I mean, that was really a great overview of custom vision. And by the way, you showed the object classification task, right? When you be determining the bird species, but you can also use that for object detection task. Did you have a chance to try it for object detection?
That's like the next step I have. One thing I wanted to try to do is to get an image of maybe like 20 hummingbirds at a bird feeder of different species, and then specifically tagging each image with the type of species it was. That's like, I think, like the next step in my personal learning journey. And in that case, it would be very more, I feel like at that point you could actually like create something where you could take like a video in the lifetime and it'll detect where the hummingbird is in the video. So creating that is like, is definitely like the next possibility. It would be a little more time consuming on my part, but it would be a super unique project.
Exactly, and you would be able to solve tasks like counting birds in the videos, and that is.
Yeah.
I think there was one nice project described on the Microsoft website as the case study when they trained the model to detect and count endangered birds. And the main idea there was that to come up with a data set, they used the video. So from the video, if you mark up the first frame, you can try to track the birds automatically. And there is a tool called Visual Object Tagging tool by Microsoft, which helps you to do that. So you don't have to mark up like thousands of images separating birds individually. You just mark up the first frame of the video, and then you have the huge data set. You can train the model. Okay, yeah, thanks so much. That was a really nice example of custom vision, and everybody who faced the problem of image classification or object detection, that's the first place to go and try customvision.ai. Thank you, Loxley, and
thank you.
Thank you. The next panel, which is coming up, is the panel about the career in AI, and I would like to invite my colleague Shanna Matthews, who would be hosting this panel. Shanna, hello.
Hi, hello everyone. Welcome to the panel. Yeah, thanks, Dimitri.
Yeah, that's so glad to see you. And I think this last panel should be like the most interesting for students, like how you should craft your career, how to become successful in the field of AI and ML.
Yeah, I hope so too. Yeah, we have some really great students here to talk to everyone.
Excellent. So let's start.
Yeah, fantastic. So I think we should start with introductions. Welcome, everyone. I can go first. My name is Shanna Matthews. I use she, her pronouns. I'm a program manager at Microsoft. My background is actually in traditional software engineering. So I will be learning along with all of you in the audience about what these wise young people have to say about careers in AI and ML. Fantastic. Ananya, you want to go next?
Yeah, sure. So hi, everybody. This is Ananya Vedala, and I am in my third year studying computer science engineering in CBIT, which is in Hyderabad, India. I am also a Gold Microsoft Learn Student Ambassador and the co-founder of a small non-profit organization called Girls Code. And in addition to that, I'm also an incoming intern at JP Morgan Chase, and I'm really excited to give in my 2 cents and learn a lot from the rest of the panelists today.
Super, wonderful. Ayan, you want to go next?
Yeah, sure. So hi, everyone. I am Ayan, final year student of Bachelor's of Technology in Computer Science Engineering from India. So like apart from this domain of computer science engineering, like specifically towards software engineering, I have been focusing towards AI machine learning from second year or a little bit early of my third year in college. So I have been doing certain stuffs, doing certain projects, and I would try to share those learnings with you folks. And apart from that, I also had the privilege of bringing the India's first Kaggle Days meetup group in India. So that's in Delhi NCR, and now it's expanded to a lot of cities in India. So looking forward to share my learnings with other panelists, and yeah, quite excited.
Thank you. Loxley, I'm sure the audience probably knows who you are at this point after your great talk that just happened, but do you want to go ahead and give people a little bit about your background?
Yeah, definitely. So I'm in my 4th year at the University of Washington, and I'm studying informatics, which is kind of at the intersection of computer science and like business and also just people. So it's a very kind of like people-focused major. And so let's see, a bit of background with me. So my background and kind of like my specialization is specifically in like hackathons. And at almost every hackathon I've attended, I've implemented AI in some form. And so I think, yeah, that's about it about me. I'm super excited to talk about like even, yeah, like speaking about the different projects I've made have even helped me get like some of my first internships, which have been like super cool.
Yeah, awesome. AI is like really good for hackathon. It's definitely one of the top technologies I recommend people use. Okay, Syed, you want to go next?
Hey guys, this is Syed Farhan from Bangalore, India. I'm a Microsoft Gold Student Ambassador from Asia region and also Quantum and AI Research Intern at IBM. My current focus is in quantum machine learning and computer vision, and great to be here.
Fantastic. Thank you. Okay, awesome. Before we get deep into the field of AI and ML, I'd love to hear a little bit from you folks about how you got started with AI and ML in the first place. What was your path? How did you discover it? And would you recommend it to other people who are maybe new? Ananya, you want to take this one first?
Yeah, sure. So for me, it was a little different as to how I started off. The reason I started off in the first place was when I attended the MSP Summit back in 2019, Jan, and there was like this video that they showed us where there was a person who was in fact blind, and he went on to create glasses that really helped him see what was around him and things like that. So that really caught my attention, and since then I thought I should get into this field. And so the way I got in was when I had got shortlisted into a course with IIT Hyderabad, and that's how I did my basics. But if I had to suggest a specific path for people who don't have access to such a course, I'd say there's so many free courses out there today. There's courses by Stanford and Coursera, which is free, and there's deep learning AI courses, and there's also Microsoft AI School, which is extremely resourceful. So there's a lot of courses like that through which people can start off. And then if you want to go hands-on, then you have Kaggle. You have so many data sets over there, and you have people giving in different approaches, and you can learn a lot from a lot of blogs that people write too. And then there's community learning that I had that helped me. I got to meet a lot of people who are interested in AI/ML as well, and I got to learn different perspectives and how to collaborate on projects, and that's how I upskilled myself. And there's so many, you can also write whatever you learn. Honestly, writing kind of clears your thought process as well. And I've done that a lot as well. And I've also read so many blogs, and that has been my journey to how I got in and how I've learned so far.
Yeah. Thank you. I noticed you mentioned Kaggle, and Aon also talked a little bit about Kaggle already. I think maybe some people might already know what that is, but why don't we take some time to define what Kaggle is and talk a little bit about Kaggle before we keep going and talk about people's backgrounds. Aon, I know you know a lot about Kaggle. Do you want to go ahead and let everyone know in the audience know what it is?
Yeah, sure. So Kaggle is a platform like where you participate, you try to participate not only in competitions, but also in discussions. Like, let's say you are starting with data science, you are starting with machine learning, but you're confused like where to start or what data should I work upon or what other folks are learning, because you want a community to grow. So Kaggle as a platform gives you the entry point to the world where data scientists learn together. Like they try to build projects, they try to compete in certain competitions and certain other events kind of stuffs. And so now you get a very good ecosystem there. Like what's the biggest part or what's the most interesting part about Kaggle is the opportunity that it gives to you to see the bigger picture, that how other folks are learning, and so that you can also take their approaches, you can learn from them, that how they took this approach, how they solved this problem. So maybe competition is one part, like where you can brush up your skills. And second is like you can make certain new data sets. Maybe you are trying to gather data sets from certain section of the country, like certain cities or stuff like that. So maybe you can make your own data set and upload that, and you never know that the data set that you made may be useful for someone in their research project, maybe useful for them in their hackathon project, right? So it gives you that flexibility on, you can also share your learnings, that whatever you learned, that yes, I coded this logistic regression, but it's through a very intuitive tutorial. So you can upload it through like kind of notebook there. And that's one part. And another part is discussion, like maybe you can try to see what other folks are learning and be a part of that. So Kaggle as a platform gives you infinite learning opportunities as a student, or even if you're just starting, it definitely gives you the exposure, or even if you have started, you can see how to progress and what is the state of the art algorithms that are being used in the world. So definitely that gives you a gateway.
Yeah, thank you. Yeah, I think that's very helpful. When I think about Kaggle, and especially when I was just figuring out what Kaggle was, I really thought it was just a place for, if you're already an expert, you go and you compete in these competitions about data science. But the platform has really evolved, and it's a great place to go learn too, even if you're absolutely not an expert. So it's a great resource. Fantastic. Okay, let's hear a little bit more about people's journeys into AI and ML. Syed, do you want to go next?
Yeah, definitely. So I started my AI career when I joined a startup named Citriot here in Bangalore, India. We worked on cutting edge technologies and various face recognition projects initially. Later on, I joined IBM as a quantum and AI research intern. So here I got to experience, the research focus of AI. AI has two different fields. I would think of it this way, wherein you improvise on the already existing models in AI, or you work on applying AI to some cutting edge technology, like quantum computing in my case. So the benefit of working with cutting edge technologies is that you get to learn about the new technology, you get to prepare yourself for what is to come in the later on career, and also skill up your AI skills while also talking to your colleagues. For example, in my case, IBM. So another thing I would like to talk about is the benefit of working in corporates. So there's a pool of knowledge if you work in corporates. You get to interact with various teams, starting from for example, software engineering side, DevOps side, or even management side. You get to interact with international clients, and my career in AI has been really fantastic. Yeah.
Awesome. Thank you. Yeah, that's very interesting. Talking about working at a corporation versus a startup versus, a mid-sized company. I know folks on this call wanted to talk about that. Let's chat about different paths and different types of careers within AI and ML for a little bit. So, Syed just expressed that he really liked working at a corporation, but I'd love to hear other people's opinions on small companies, big companies, what's the best place to start your career or develop your career in AI ML? Loxley, do you have any thoughts?
Yes, I do. And I've actually been exposed to both kind of AI within a startup and AI at a massive consulting firm. And so at a startup, I feel like the super cool thing about being at the startup is it's just a super small environment. So you're given more responsibility. So I was, as kind of the data science intern for the project, I was working right with the PhD machine learning graduate who is creating the super complex models. And so I was working very closely with him. So I feel like you have a little more of a hands-on work at maybe this smaller role. And I think one thing that was super interesting is they were creating their model from the ground up, which unlike at the more bigger firm I was working at, in comparison, so instead of having everyone working in the kind of ML data science reign at a small firm, in the super big company, the team working on the AI was the innovation team. And so kind of you had to find a way to position with yourself and kind of speak to all of your managers and say hey, this is the work that looks really interesting to me and where I see myself having the most impact, and then finding a way to get yourself to that innovation team where they were implementing cloud solutions such as custom vision for their clients. So I would say that's the biggest difference is the small AI startup, everything was AI. At the bigger firm, you had to find a way to transition to the team that was specifically working on the AI stuff, which is just a very interesting kind of dynamic when you're trying to figure out what you want to do right out of college.
Yeah. Did you feel like one was better for a beginner in some way, or did you feel like they both kind of had their opportunities to learn?
They definitely both had their opportunities. I feel like at the startup, you're more hands-on, so you're doing more of the learning aspects. But at the same time, and there's also just a lot of opportunity to grow. But at the bigger firm, we were like the impact that the innovation team was having with AI was just so grand that like on either side, it's like one side you'd learn a lot, and on the other side you would still learn, but you'd have a massive impact that was like kind of really changing our like the client's like workspace. So I feel like both are beneficial. I mean, I would say personally, I'm leaning more towards the bigger firm just because like slightly more stability, and then I just felt like the innovation space was really cool. But I mean, the startup was also a really great place to learn all of this stuff at like kind of an early time, which is pretty neat.
Cool. Anyone else have thoughts they'd like to jump in with about their experiences, maybe with bigger companies versus smaller ones?
Yeah, I'd like to talk about it. I haven't worked with a big company yet, but I've worked at a startup, and I really like the experience there because you're not restricted to one domain. So there's so much work that has to be done, and there's not a lot of people. So you get exposed to a lot of other technologies, not just what you're expected to do. And that really helped me as a beginner because that was the first thing I'd ever worked on. And I got to learn multiple technologies, I just didn't stick to the AI role that I was expected to work on. So yeah.
Awesome. Thank you. Yeah. Any other thoughts? Oh, thanks.
Another thing that I want to add upon is like in startups, it's like you are one-man army, right? So let's say you are a data science intern there or an AI intern there. Now you also talk with clients, you also participate in the calls of your clients. And in turn, like not only your technical skills are improved, but communication skills also gets improved, right? Because you get to participate in the client's call, like because it is my personal experience that I interned at a startup. So I had to get on a call with the client too, that what his or her requirement is, and you get to know the entire pipeline, that what my end product should look like or what's the deliverable that I'm expected to give, right? So you get a very big picture in a startup, and you can be a part of that product right from the 0th level, right? So maybe like what happens in big startups, maybe like there is certain a building block or a foundation already there, and you sit on top of that and innovate on top of that. But in startups, it's like you are the person who are setting that building block or setting the foundation stone. So maybe for a beginner perspective, sometimes it becomes very hectic. Like sometimes at a startup, there is a lot of like hard work going on. Like you have to sit for around 8 to 10 hours just to figure it out, that how should I lay the foundation stone, right? So it's sometimes any technology might work, any technology might not work. But in case of bigger organizations, maybe you know that roadmap, that yes, I should move this way, and I have my manager who has been doing that work around 2 to 3 years, and he can guide me. But in startups, the founder is also like, hey, you are the man, like I just want something out of you. So you get to explore a lot, and you are thrown into ocean that you have to swim now. So that's a hell lot of opportunities out there. But in bigger organizations, the circle and the innovation level that Loxley talked about, right? So innovation level comes with like there are 1,000 people. So the combination of innovation is really great. But in startups, it's like 10 people. So like the innovation scale might differ. But like every level of company has its own advantage. But what I would suggest for a beginner is like get something, right? You should not be in the thing that, oh, I am not getting big companies, so I should not go for startups. So do not be in that thinking that I would only go to big companies. So for learning, you have the open ground, be it startup, be it big organizations, just go and explore.
Yeah, thank you. I really like that takeaway. I think different people are going to have different preferences about where they work best and where they think they can learn the fastest. But no matter what, getting your foot in the door at a company, be it big or be it small, is a great first step. And even if it's not the perfect fit for you, like that's okay. You have plenty of time left. Plenty of future left in your career to figure out exactly where you want to be. Awesome. I just wanted to take a sec to remind the audience, if you have any questions for the panelists, please drop them in the chat. We'd love to hear from you, know what's on your mind and the questions you'd like to get answered. Thank you. We appreciate your questions. Yeah, perfect. So let's keep talking about different kind of sub areas within AI and ML careers. Let's talk about some different kind of areas you can specialize in. What are different focuses you can have for your AI and ML career? Maybe what are some ones that are less common that people in the audience might not know about? Let's see. Syed, let's throw that one to you.
Yeah, sure. So if you talk about the most common domains which people think about in artificial intelligence, you think about computer vision applications, which almost everyone is pursuing these days. We have natural language processing, speech processing, which most of them are working together. Another area which is not very much explored is digital signal processing with AI. So this is a very strong research focus area which electrical engineers are usually working on these days. And if you combine that with AI, it has really great potential in medical applications or applications in the film industry, for example, or in different sectors of industry wherein you have speech processing involved. Another area I can talk about, which I'm currently working on, is quantum machine learning. So we know about quantum computing and how the paradigm of quantum computers is going to revolutionize the world in the next few years. And combining it with artificial intelligence, basically HQC architectures, wherein you have hybrid of quantum and classical architectures, you're able to achieve much more than what normal classical computers can achieve. You're able to solve the problems which are unsolvable by computers these days. And there are multiple other fields which coincide with the medical industry. They coincide with nanotech industry. And if you want to explore any more industries, if you're interested, you can ping me later on and definitely get back to you guys.
Wonderful. Thank you. Any other thoughts from panelists? I think you did a great job in enumerating a bunch of the different areas that people can focus on. But yeah, any other thoughts? Super. Okay. We did get one question from Amy Boyd. She wants to know how all of the panelists keep up with all the latest advancements in AI. It's obviously a field that moves very quickly. So how do you try to stay up to date? Go for it.
All right. So the field with AI is, it's really advancing. We have tutorial videos coming out. We have blog posts coming out almost every day for a research that's happening, for example, in Microsoft's lab or Google's lab. Let's say the research happens and within the next 24 hours, you have a new video coming out. So you watch the latest news about AI and you keep yourself up to date. But in fields like quantum machine learning, the progress at which you have new material or new content coming up is not that great. So you have to read up research papers. You have to subscribe to, for example, Springer or Nature or different areas wherein you can read research papers. I personally prefer IEEE Explore. We have Archive for that matter. So reading research papers is a really great habit, and if you guys cultivate it, it's going to help you in the long run, because the moment the paper arrives, it's not that you get to watch a video or read a blog about it, but you can go ahead, have a look at their new equations, have a look at the code that they have, and try to reproduce it so that you guys can get to actually try out what has been tried out in that research lab, which has brought out the AI research.
I'd like to add on to that. So I think if you want to keep yourself updated, there's two things that that can really work well. One is community learning. So I cannot emphasize enough on this. So the Microsoft Learn Student Ambassador community, we have a league called the AI ML League, which is organizing this with global AI community. When there's a lot of people doing a lot of things every single day in this field. So whenever they do something new, it's out there. So if you're keeping up with that, you pretty much know what's new and what's not. And another thing is Medium. You get article updates every single day if you subscribe to them, and every day there's something new. So just take out like 2 minutes a day or probably 10 minutes a day at max in the morning and just read some new article that they suggest to you, and you're good to go for the day. So so those two things I think really help me keep in touch with whatever new comes out in the field.
Awesome.
I could hop in very quickly too. I wanted to say everyone has said so far. also agree, but I had 2 more things that you could also do. So number 1, I recommend on the kind of community learning is attending the hackathons, the local hackathons at your school. I feel like the place where I see where the coolest AI implementation by students is happening is at hackathons. And I always keep my eye out to see who like the finalist teams are, because the projects that they are doing are using AI, but they're also using it in like innovative and creative ways. So that's my first piece of advice. And the second piece of advice I have is to engage in research at your college or university, because I engaged in as part of a research seminar last spring, and we were specifically focusing in how like deepfakes was affecting social media and how like our perception of like how accurate like our social media feeds were. And so working with like the leaders in a specific field and like kind of seeing what they have to say is the best way to stay like up to date, informed, and learn really cool things along the way.
Another last thing that I would love to add is like, because the other panelists have really added a few important things, but one of the most important thing is do not be in the fear of missing out thing, right? Because do not think that if I do not read this article, I would be left behind. So it's not that you have to read every algorithm that comes out in the market or every new state of the art thing that's going in the market. It's okay to go slow. If you're focusing on computer vision at this point of time, try to skim through the resources. It's not that every article is of your use now. I'm not speaking that those articles are not good or those articles are not up to the mark, but try to focus that, yes, I am working on this domain and I want to get knowledge on these things only as of now. So try to focus and do not be in that thinking that, oh my God, my friend is doing certain stuffs. The same thing happened with GPT-3. The world went crazy, right? GPT-3. And it was like, when it comes to real world, it's really tough to implement, right? So do not be in that hurry that, oh my God, the world has gone to GPT-3 and I'm not able to implement even GPT-2, stuffs like that. So do not be in that. It's okay to go slow, but everything that you do, try to focus on the basics, because even if you try to do the most advanced stuffs, but if your basics are not clear, it may be a really challenging task for you to clear the interviews or the hackathon rounds or stuff like that. So try to focus on basics, and it's okay to go slow. And yeah, every time you have resources, subscribe.
Yeah, that's a great reminder. Thank you. There's just so much change in the field of AI. It happens so fast. It's hard to keep up. So don't feel like you have to keep up with every little thing. But if you're a beginner, do focus on those basics. That's great. We got a few more questions from the audience, and I'd love to try to get through them. And we've only got about 5 minutes left, so we got to go into a bit of a speed round. Okay, we have a question from Twitch from DP the Gray. He wants to know, how do we start directly into ML/Ops and start at an architecture level, or are there any suggestions related to careers in ML/Ops? Do any of you panelists have any experience or knowledge about ML Ops?
Yeah, I can go ahead. Maybe like if you're trying to focus on ML Ops, the best thing that you can learn as of now is Docker, right? Docker for data science and Docker for machine learning. And maybe you can scale it up to Kubernetes and stuffs like that. These are really useful for scaling your application in real world. And like, if you're focusing on these ML Ops, so try to keep updated yourself with these things like Docker and productionizing those stuffs, because how to make a pipeline, how to do those things. So because it's a new thing that's coming up, and it's really important to keep pace with. So Docker, Kubernetes is one of the most important thing that you can focus upon.
Awesome. Yeah, I totally agree. Docker and Kubernetes are extremely important for any kind of ops domains, even just regular software engineering too. They're really, really important skills. Okay, Jade wants to know, do people think there are certain strengths or personality characteristics that make someone a better fit for careers in AI and ML? Anyone have thoughts on that?
I think I could input on that. I feel like, honestly, I don't really think that there's any characteristic you need other than kind of having a growth mindset, like the desire and passion to like learn new things and be open to learning new technologies. I feel like that's the only thing you need, is just an open mindset, going into something with an open mindset.
Yeah, I like that. And I'll just remind people, if people aren't familiar with the term growth mindset, it's the idea that you're the things you're good at and the things you enjoy, all these things about you are actually fluid, and it's about practice and intention and trying, rather than just assuming that, the things that you're really good at are fixed, or maybe how good you are at certain things are fixed. So growth mindset is really all about keeping an open mind. And even if you think maybe you don't have a growth mindset right now, having growth mindset means that you can get a better growth mindset. Super. Let's keep it moving. So Jade was also curious, can you join hackathons if you're not currently a student?
I can quickly hop into this one too, and I feel like most of the hackathons that I'm currently aware of are for students, but I know all of the hackathons out there are looking for volunteers and looking for mentors from people who currently aren't students. And I also know that there are some hackathons out there that are for, like, I think, working professionals. I think the Meetup might have some communities that host hackathons, so be on the lookout for that. But also, like, volunteering or mentoring at hackathons is a great way to be kind of exposed to the learning opportunities there as well.
Perfect. Thanks, Loxley. Okay, and Jez wants to know from the panelists, have you always worked on projects in your own region or country, or do you ever work on projects with people from other countries? If you do that outside of your country, how does that work in practice as far as contributing to that project? Syed, I can see you nodding. Do you have any thoughts?
Yep. So I've worked on both kind of projects, projects within my region in India and also international projects. So as far as talking about international contributions, open source is a great way of contributing to AI code that you already have. But if you're working on research projects, then you would not particularly want to contribute in an open source environment, when you can use GitHub private repos in that case, or you could just create Bitbuckets, private Bitbuckets for having your research work. And yeah, talking about international research, I haven't had the opportunity of going out of my country for research, but everything has been virtual ever since the pandemic. So it's all about meeting new people. It's about discussing new ideas and making sure that you're able to convert that to a research paper or particular code that actually works.
Wonderful. Thank you very much. I think we are pretty much at time right now. I appreciate all of you panelists coming and taking time out of your day. I know I learned a lot. I hope everyone in the audience did too. So thank you.
Thank you.
Thank you. It was great being here.
Thank you.
Thank you, Shana. That was really a cool panel. So many questions and so many viewers actually specifically tuned in to watch this career panel.
Yeah.
So thank you again. And in fact, I want to mention that this conference is a truly international project, because we have people watching from many different countries, from India, from Russia, from Europe. And the fact that you are watching this conference is already like a good start into international projects, and there are no limits, especially during pandemic, to the internationalization of the projects.
Yeah, I love that. Thanks, Dimitri. Okay. Hey, Dimitri. Oh my goodness, we are at the end of the day, right? That was all the sessions. My brain is exhausted.
Yeah, I wonder if we are the only ones who watched this conference from beginning till the end, or we have somebody from our viewers who did the same. That would be interesting to know. So if there is someone like that, can you please write in the chat?
Yeah,
and
no,
we would
let
be
us
really
know.
curious to know.
Cool. So I wanted, before we wrap up, we've got a few call to actions. So you have watched so many different talks here. And so what we want to do is I want to just give you that reminder that right below me, right here, aka.ms/AI/challenge is where you can go and get hands-on with our Cloud Skills Challenge. Now, what is a Cloud Skills Challenge? It is basically a set of Microsoft Learn modules that we have put together specifically for this conference that you can go through. And if you complete them, you get onto a leaderboard. You have a full week. So come back to this website on the 19th of December to see where that leaderboard's at.
And then basically we will publish some results around the 21st of December, and you could be getting your hands on a swag gift. So if you want some swag from this event, then do get involved, but also just some great learning. We've seen Microsoft Learn come up all across this conference, and in the resources page, there is also some links.
And there have been so many talks today, and if you had to miss some of them, or you were sleeping when they happened in the beginning of the day, you have the recordings of all sessions at the conference website, aiconf.education. So you can always go back and rewatch the parts that you liked, or watch whatever you haven't seen. And feel free to share this address with your friends as well, who might have missed this conference and who want to learn more about AI.
Absolutely. Speaking of learning more about AI, as if I've not written it enough in the chat today, do go to that resources page. So it is aiconf.education/resources. And every single one of our speakers has given amazing links for all of the content. So code repositories, learning resources, recommendations, as well as social links, so you can keep in touch with some of our speakers.
And actually, we have covered a lot today, but there are some topics that we haven't talked about. For example, I would definitely want to hear some more talks about generative adversarial networks, about training AI to produce art, and about some practical projects that students do around AI. In fact, some of the student ambassadors, they also expressed the wish to do the talk, but they did not have enough time to prepare for this conference. So we are definitely thinking of repeating this sometime in the future. So maybe sometime in the beginning of 2021, you can expect one more conference like this. And if you do want that, please write in the chat that we definitely want to continue, and that would help us get this project ongoing and prepare more and more interesting talks for you.
Fantastic. Well, I guess on that note, Dimitri, that's goodbye from us. Thank you everyone for joining, and we hope to see you again soon. Bye.
Goodbye.